Mantra, you're on mute.
Good morning and a hearty welcome to all attendees and participants of the Autocar Professional EV Forum. This is the third and final day of this mega virtual event. And what the first 2 days have been no less than absolutely packed in terms of information, participation, and engagement also of the attendees, with no less than 10 sessions, which included 4 panel discussions, 2 keynote addresses one each by a central government representative of India and one from a global automotive industry leader, and with some very highly informative techno-commercial presentations in between. So we have got representation from across the spectrum, from startups to large OEMs to two-wheeler manufacturers, central government and state government representatives, and the CEO of India's policy-making body, Niti Aayog. Amazing 2 days, and I'm pretty sure this last and final day will be equally interesting, which is, as we have seen, it's called the Celebrating Innovations. It's the Lanxess Innovation Day. So let's see what we have in store. And to tell us more about it, I now hand over the reins to my colleague, Mayank Dhingra, who is a special correspondent at Autocar Professional. Good morning, Mayank, and over to you.
Thank you very much, Mantra, for flagging off the day 3 of the Autocar Professional EV Forum. And quite uniquely, we have ideated this as the Innovations Day led by Lanxess, which is the leading specialty chemicals company, registering global sales of 1.6 billion euros in 2020. It currently has about 14,800 employees across 33 countries, which makes Lanxess a truly global multinational. The core business of Lanxess lies in the development, manufacturing, and marketing of chemical intermediates, additives, specialty chemicals, and plastics. Its high-performance materials, or HPM business, works very closely with the automotive and transportation industry. And to tell you more about Lanxess and its innovations, I would now like to extend a very warm welcome to Mr. Pankaj Khare, Business Unit Head and Head of Sales and Marketing of High Performance Materials at Lanxess India. I would like to give a very brief introduction about Mr. Pankaj. He has obtained a degree in engineering in plastics and mechanical and PGDBM from Narsi Monji Institute of Management Studies from Mumbai. He has over 30 years of experience in the industry of engineering plastics. Prior to joining Lanxess, Pankaj has an experience mostly in multinational companies. He has had stints in companies like DSM Engineering Plastics, DuPont, LG Polymers, and he's currently working with Lanxess in the High Performance Materials business unit for over 9 years. Over to you, Mr. Khare, and we would like to get an insight into Lanxess from you.
Thank you, Mayank. Good morning to Autocar Professional team. Good morning to all the attendees. Before we really get into the subject, I'm going to just give an overview about what Lanxess is all about. Let me share my presentation with you.
You're good to go.
Are you able to see the slide?
Yes.
Okay, so I hope the attendees here know about Lanxess, but there might be few people who don't know about Lanxess, and for that, to the benefit of these attendees, I would just briefly share what Lanxess does and how Lanxess does. These are the presenters from Lanxess side today. Mr. Axel Tuklinski, he's head of global product and application development in Lanxess. Global product and application development sits in Germany and joining us from Germany today. Thank you, Axel. Mr. Jorgen Zillig, head of application development APAC, and he's also in charge of our e-mobility initiative in Asia Pacific, joining us from Hong Kong today. Thank you, Jorgen. And myself. People who don't know about Lanxess today must be knowing about Bayer, and then we were part of Bayer before. In 2004, Lanxess actually Bayer decided not to participate in some of the businesses they were doing, and then they separated those businesses out. Those businesses were listed on German stock exchange called DAX, and then we were asked to feed for ourselves. That's how Lanxess was formed in 2004. And then it's a fantastic turnaround story, I would say. Currently, we are more than 6 billion euros company with presence in 33 countries and more than 14,800 employees all over the world. We are in consolidation phase in Europe and in expansion phase in US and Asia. 4 business verticals, and then Lanxess totally has got 11 business units currently. The latest addition is flavors and fragrance, and that belongs to consumer protection business vertical. A very interesting business unit to start our business with, although we had some part of that business unit also before. The advanced intermediates consist of advanced industrial intermediates and inorganic pigments. Specialty additives business vertical, 3 business units, lubricant additives, polymer additives, and Ryan Chemi. Consumer protection has got 4 business units, F&F, liquid purification technology that we call LPT, MPP, material protection products, and Saltigo. And the business vertical that we belong to is engineering materials. Our business unit is called high performance materials, and you will hear the word HPM quite often. So that is high performance materials, and we also have got urethane systems in engineering materials. If we talk about HPM, high performance materials, more than 600 customers, more than 1,500 employees, and we are among the top global 4 engineering polymer suppliers in the world in our area of business. Some really interesting applications have been listed here. Front-end module, I'm going to talk about it a bit later. And then strong setup, global setup. We are basically a European company, so we have a strong presence in Europe, in Germany, and also in other parts of Europe. But then we are also present in US. We are also present in Brazil, we are also present in China in a big way, and then we are also present in India. And global quality is guaranteed by uniform production standards worldwide, and that also will be coming a bit later. We have got a global approach as regards to product quality and product availability is concerned. These are the global compounding networks in red, and then sites of upstream integration in black that we are able to see today in this slide. Backward integration, Lanxess is extremely highly backward integrated. We have our own caprolactam plant in Antwerp, very near to our polymerization plant. So we are one of the biggest polymerizers of polyamide 6 in the world, and we are also one of the biggest producers of caprolactam, which is input raw material for polyamide 6. We are also having our own glass fiber plant there at a very similar same location. And then we, being a chemical company, we are also making a lot of additives and pigments and FR ingredients that we use. So I think whatever we are using in our compounding activities, compounding plants all over the world. Many of the things are produced by Lanxess somewhere in the world. And I believe such a brilliant backward integration, very few in our competition have got. Our GPAD, Global Product and Application Development Center, we have Axel today as a presenter. He is a head of global PAD network, and a brilliant setup today, which really adds value to the whole development activities of our customers. We have got support for our customers as regards to product development, as regards to R&D testing center. We have got a huge investment done in testing center, and basically, we can really test and validate the components in our R&D facilities. Then we have got application development center, and then customer engineering services, where we support our customers in designing, in material selection, in computerized simulations, in prototyping, in tooling, and also in processing and then testing and validation. So entire development cycle, you can really count on us, and we will always be always there to support you. This happens in Europe, in Germany, and then we have got a very similar structure in Hong Kong to support our Asia Pacific customers. Location is Hong Kong Science and Technology Park, a very prestigious area to be in, on the banks. And then we really we are having a very similar setup that we have in Germany. Then we cater to all our Asia Pacific customers from here. A brilliant set of experts, a very knowledgeable team out there in both the places, and then a great support for our customers. Just to give you some examples of what we have, you are able to see the air intake manifold under testing in this laboratory. But if you talk about whatever test benches we have got, we have got shaker test, compression test, pressure precision test, backfire test, climate test, drop test, stone impact, also very important for oil pans, different welding test, leakage tests. So I think many component level tests that tier 1 requires to be done, or OEM requires for testing and validation of a component. We have all the test benches in our facilities here. And our customers are also using them for testing and validation of their components. Shaker systems, pressure pulsation test. You can see temperature ranges from -40 degrees to 150 degrees. Vibration testing systems, again from -70 to 200 degrees Celsius. Coming to India, we have got a state-of-the-art plant in Jagadia, wherein we compound engineering polymers to make it suitable for your applications. This is the photo of our Jagadia plant. Jagadia is the place very near to Baroda, very near to Bharuch actually, in the state of Gujarat, around 80 kilometers from Baroda. Some pictures of testing laboratories. We do a lot of raw material inspections, quality control out there in our plant. State-of-the-art lot testing devices also are there to support, ensure that we deliver global quality to our Indian customers as well. Our brands, Durathan and Pocan. Durathan is polyamide brand, so we have polyamide 6 and polyamide 6.6 there, and then we have got PBT. As I was talking about in polyamide 6, we are really backwardly integrated with caprolactam being the input raw material, with glass fibers and additives and pigments. We also have got PBT polymerization plant in Europe. And then if you talk about India business, we are very much automotive centric. Around 50% of our business comes in India from automotive. 18% comes from electrical and electronics. And then in this area also, we have been catering for long now. 10% comes in two-wheelers. We don't consider two-wheelers as automotive, so two-wheelers has been separately listed out here. And then industrial and household and others. We started our production in India in Jagadia in 2012, and the capacity there is 20 KT per annum. Where are we present in the car? I mean, in automotive, we have been catering to car applications for long. I think our Durathan brand is about 80 years old, 80. And that is the expertise, the knowledge that we have got in automotive field. And then we are almost present everywhere in a car. We are present in interiors, exteriors. Under the bonnet is the area that we love to work in, around the engine and in chassis and whatnot. I mean, we have just listed some applications here: seating systems, engine mounts, oil modules, front-end module I was talking about, and front-end modules in polymers in PS6 was introduced first time by Lanxess around 15, 20 years back. And then, today, so many cars are having polymer front-end modules today. And now I think another area that we are really loving to work is cross-car beams that we are already working. Engine oil pans also is the area that we want to work in India as well. And then air intake manifolds, gear shifters, radiators, water tanks, coolant manifolds, fuel tanks, and whatnot. We have a regional structure in India. India being a very big country, we have an office in North, which is North business is managed by Vishal Srivastav, who is the head of North India business and also manages East from there. Nandini Kulkarni is our manager for West India, sits in Mumbai in our Thane headquarters. By the way, Thane is our headquarters in India. And Nandini manages Western region business from there. Shashi Shankar sits in Chennai and then is a manager for Southern region. And then Sachin Zagde is head of technical marketing in India, and he supports all India customers in all the technicalities of the business. I have listed the email addresses of all the 4 guys here, and then feel free to get in touch with them if you need anything related to engineering polymers, related to your businesses, any technical input. We are always there to support. These are the 3 gentlemen. I have purposely wanted to say thanks to these gentlemen. These are a few of our strategic customers. And these 3 people, these 3 top executives have given us the video clips today. And they have spoken about what they feel about Lanxess. So one is Mr. Vishal Kabadi. He is a president, Lighting and Electronic Division in Samardha Motherson Group. Mr. Sandeep Deshpande, VP Procurement and Sales of Male Anand Thermal Systems. And then Mr. Prasad Sharma, AVP Sourcing and ASQ in Sojefi Engine Systems, India. Mr. Vishalji, Sandeepji, and Prasadji, thank you so much. We will be playing their clips very shortly. And I really thank them for our association. It ranges really, I think, beyond 10 years now. We have been catering to all these 3 gentlemen and their organizations. I think I'm coming to an end of my presentation, just an overview about what Lanxess is. But I think thanks to our customers, Lanxess has established globally as well as in India as a reliable and sustainable partner and knowledge maven for our Indian customers as well. And then we now want to really, take this story across our expertise, our knowledge base in automotive and E&E sector to e-mobility customers as well. And we have already started working with many of the e-mobility tier 1s and OEMs also. So we look forward to, continue our association and, really take this to the logical conclusion as far as success of our both businesses are concerned. Thank you very much. Before I hand it over to Mayank, I think I also request Mayank to play an first video clip rather. That is of Mr. Vishal Kabadi. Mayank, can you please arrange that?
Hi, good morning, ladies and gentlemen. My name is Vishal Kabadi. I head the Lighting and Electronics Division for the Motherson Group. Very glad to be here to speak on behalf of Lanxess. Lanxess is one of our leading suppliers for engineering plastics in the Motherson Group. Our association with them goes back to almost a decade when they introduced new materials for us and helped us in various simulations for our air intake manifold business in plastics for various customers like Suzuki and Mahindra and Mahindra. We further grew this relationship and added them onto our lighting panel as well, and are glad to see that they are one of our largest suppliers today in the field of engineering plastics. As they take this new target towards being sustainable and to become a carbon neutral company, we have to understand that sustainability is no longer a buzzword in the industry, but is the need of the hour to make sure that our future generations remain safe. I wish them all the best, and I'm sure that under the current leadership, Lanxess will achieve new heights and create new benchmarks in the industry. Thank you.
Wonderful. Thank you very much, Mr. Khare, for giving us a snapshot on the global standing of Lanxess.
Thank you.
And we've got a testimony from one of your customers, Motherson. And you've mentioned that Lanxess loves to work with components which are under the bonnet, but as we all know, we are seeing the dynamics changing. And now to dig deeper and learn more about Lanxess, we move into a one-on-one conversation session that would give us an understanding about how Lanxess is positioning itself in the electric mobility space. I would like to invite Dr. Axel Tuschlensky, Head of Global Product and Application Development, High Performance Material Business, Lanxess. And to interview Dr. Tuschlensky, I would like to invite Mr. Hormaz Sorabji, Editor, Autocar India. Good morning, gentlemen. Looking forward to a great discussion. Over to you, Hormaz.
Thank you, Mayank. Thanks very much. And hello, all attendees and fellow panelists to this next session of the EV Forum, which I'm happy to moderate. And in this session, we are in conversation with Dr. Axel Tuschlensky, who Mayank just introduced. He's the Vice President, Global Product and Application Development, High Performance Materials Business at Lanxess. Dr. Tuschlensky has a rich background, about 20 years of professional experience in the chemical industry. He holds a PhD in chemical engineering. In his current role, Dr. Tuschlensky is responsible for research, research development and innovation of the plastics business at Lanxess. The focus is to provide innovative polymer solutions for applications in new mobility, such as electrical powertrains, fuel cell cars, charging infrastructure, and autonomous driving. Dr. Tuschlensky and his team are playing an important role to make future mobility even more sustainable. And with that, I would like to welcome Dr. Tuschlensky and kick off this session. Welcome, Dr. Tuschlensky.
Hello.
To start, thank you. Thanks for joining us. And just to kick this off, just a broad view on, what is the scope for performance polymers during this transition from IC engine to EV? I think this is the big transition that is gripping the industry, how quickly to transition from IC engines to EVs, because a lot of manufacturers have also announced that they will be going pure EV by the end of the decade. And, just from the performance polymers point of view, how does this impact you all?
Well, first of all, Hormaz, thank you very much for this kind introduction. I'm very, very glad and honored being invited as a panelist for this very interesting forum. Hello and good morning to all participants from Germany. To answer your question, it's an exciting transition of the entire industry. I mean, we at Lanxess, we supply solutions to the automotive industry for more than 30 years, and a lot is related to applications under the hood. So with polyamide, this is being used where it's hot, where you need a good mechanical performance of the material, where you need good chemical resistance, and all this is fading away now with the transition of our industry to electromobility. And we at Lanxess, we have started basically back in 2016, so already 5 years ago, at a time when this big Dieselgate just started in Germany and also in the US, By that time, we already felt that something is changing, and we founded an e-mobility group consisting of engineers and chemists. And we put pretty strong emphasis on developing solutions for the electrical powertrain. And meanwhile, we see even bigger potential for engineering plastics in the electrical powertrain than we have today in under the hood applications. So we rather see more opportunity, more growth potential than before.
Sorry, I was on mute. Yeah, you know, that's interesting. You said that you had seen the whole issue with Dieselgate, you know, and you're seeing this transition as well, moving away from diesel more towards non-diesel products and even EVs. But, you know, I think what are the challenges with the EVs? You know, with IC engines, one would imagine, as you had said, you know, high thermal loads, heat, that sort of thing, which seems to have gone. Are there any kind of challenges or areas in EVs that are coming up, which you know, obviously, which you'll need to focus on?
Yeah, absolutely. I mean, you have completely different and new material requirements.
Exactly.
Giving you an example, everything what is related to the traction battery. Whether you take connectors or battery modules, frames for battery modules, housings, all these materials, they require flame retardancy. Yeah, no halogen-free flame retardant material. This is a material requirement which was so far completely unknown to the industry. Yeah, and now OEMs are asking for flame retardant solutions. I mean, just for safety reasons. Another example, we will also come to these examples in more detail in our presentations. Orange, I mean, everything what is related to the to high voltage, everything beyond 48 volts, has to be equipped in orange just for safety reasons, and it's not easy. Just imagining, I mean, polymers, they have aging properties. They turn brownish when they're exposed to higher temperatures, especially polyamides, and maintaining a color for a period of 10 years, maintaining an orange wall over the entire lifetime of a car in orange, this is tricky, and you need to develop material stabilizers. You need to develop new recipes to deliver that kind of function with the material.
Right.
So on one side is basically product development, and the other part is, of course, also developing new applications. So it's both.
Right. And as you said, you know, moving to high voltage from 48 now all the way to 800 volt architectures, which, you know, a lot of OEMs are giving. But Dr. du Plessis, just one little bit of a prickly point, which the EV industry is, you know, has yet to give a proper answer, is on recyclability. Clearly, this is one issue, and you know, you talked about the aging process of some of your materials. Where do you think, you know, your contribution could be in this going forward?
Well, sustainability is on the very top of our agenda. LANXESS committed itself to be climate neutral by 2040. And in addition to that, we are also working on pretty specific solutions for circularity. So one is basically reducing the carbon footprint of our material in scope 1, scope 2, and scope 3 emissions. And second is also closing the loop. So basically not producing, using, and dumping. It's rather closing this loop. We, in 2 weeks from now, we will launch. There's a big plastics fair in Germany, Fakuma. I don't know if you are aware of that. This is one of the bigger fairs on plastics in Europe. And we will be launching the first 100% sustainable material consisting of recycled polymer and recycled glass fibers. So this is pure recycling, but it's not like second quality, it's prime quality, and this makes the difference. So we never compromise on performance when we talk about sustainable solutions. It is premium quality, and this is what we pay a lot of attention to.
Right. Just moving all over to a macro picture, which is, let's say, growth in the EV industry across the globe and the potential foreseen in India. Now, obviously, India, in terms of our EV footprint, much smaller right now, but governments have made a lot of commitment. There's a lot of positive noise so far, but to be honest, it's just a lot of, let's say the action is yet to be seen. But what is your sense on how the EV industry is growing globally and also the Indian potential?
This is, we also looked into this, and we also made, and later in my presentation, I will also show one slide which indicates how we tend to underestimate the trend. So basically, what we see now is a penetration of battery vehicles, which is much faster than we have expected 2 or 3 years back. In Europe, with the European New Green Deal, there are pretty strict regulations coming into play. For instance, in 2035, no combustion engines will be permitted anymore. So basically, the sales of new combustion engines. The Biden administration in the US, they have the target to sell 50% of battery electric vehicles by 2030. China is moving forward. So, and I think India is now also picking up, mainly, most likely for 2 and 3 wheelers in the beginning, but later on maybe also for commercial vehicles and buses. Yeah. So our experience from when we started back in 2016, 2017, we also estimated powertrain scenarios, how they will kick in. We completely underestimated the dynamic of this industry. And what we have now in what I can tell you about Europe, and I think this is also going to happen in other countries, other continents. There's such a momentum in this transition that OEMs and also tier suppliers will be somehow, everything will be turned inside out. There's such a big change. We never believed that this is going to happen so fast and with such a high pace.
Right. I think this seems to be a pretty common narrative that, the pace of electrification has caught a lot of people out, and, it's sometimes hard to predict as well. And clearly it is growing faster and probably might even beat a lot of forecasts. So just to understand, how prepared is Lanxess for this growing demand? I mean, in terms of investments, are you kind of accelerating the pace of that, for products and services to cater to this growing demand? Do you need to relook at forecasts from time to time and maybe, revise, let's say, what projections are going forward?
Yes, absolutely. We are prepared, and of course, we also are trying the utmost to accompany this growth and also the change in this industry. Capacity-wise, I think Pankaj explained. We have compounding facilities all over the world. We just recently completed a capacity expansion in Germany. We are thinking about adding additional capacity in Asia, and we're also thinking about adding capacity in the Americas. This kind of investments, you are much more flexible than the lead time is not that long as you would need for an upstream like a caprolactam facility. So we are quite flexible and also fast in adjusting our capacities to the need. In addition to that, of course, we also have a global supply network. This means we can also shift capacities from one region to the other.
So just to get a sense, what is the sort of lead time you would need, when you suddenly see a certain spurt in a certain market and you feel you need to kind of put in capacity quickly?
Typical lead times for compounding facilities, once you have taken the decision to start up, I would say 18 months.
Right. Yeah, so you're right. I think you have a good flexibility there and are well placed to react to the way the market is growing. But I just like to maybe get your sense, look at your crystal ball. What is your view in the next 5 to 10 years of the EV industry? If you any numbers you can share. I know it's in this very kind of volatile age of pandemic. There's so much flux going on. It's hard to predict what will happen sometimes next month. But just looking into your crystal ball, 5 to 10 years, where do you see? Do you think we will be much faster than we felt? And if you could just share some broad numbers with us.
Yeah, I will also share later on our view and also scenarios from consultant companies. So we expect 40% of battery vehicles by 2030 in Europe and in China, slightly less in the US. India, to be honest, we still don't have a good feeling for India because it's now kicking in. But I can also well imagine that once there are also government incentives coming into play, that thing is also kicking up. So yeah, 30% by 2030 in the US, 40% in Europe and China by 2030. Well, any projection beyond that is of course difficult. Yeah.
Yes.
And we also, in addition to that, we also believe in the hydrogen economy. Yeah, this is another thing which is not being considered at all, but we are a strong believer that this is also an alternative powertrain technology.
Absolutely. In fact, I was going to talk about the charging infrastructure industry, which is something which hydrogen doesn't need. So before we get to that, I just want your thoughts on hydrogen, because, this seems to be, we've had certain announcements of basically, the cost of hydrogen, realistically, it could come down to a level where it is economically feasible to kind of explore that technology on a mass scale. We've heard certain announcements even from big Indian industrial houses saying that they're looking at that, and especially for markets like India where you've got long distances, it really helps for the commercial segment. Do you think hydrogen may though a late starter, but frankly that could be the eventual silver bullet for going towards zero carbon?
I'm a strong believer of the feasibility, the technical and also commercial feasibility of hydrogen, because simply you have to make. If we look, for instance, in Germany, we do not have enough space to bring in all the to supply all the electricity which is needed for the industry just from renewable energies. So this energy has to be imported from areas like Africa, the Middle East, and I think in India it's the same. Yeah,
right.
you need to store the energy and you need to transport the energy, and hydrogen is just a perfect vehicle to do so. And from that point of view, even though you have losses in converting the energy into hydrogen and then back into electricity, simply the fact that you have to transport energy, and in certain areas there's just not enough capacity to provide electricity, you need hydrogen. And we have also in our portfolio we have technology in place to coat the inner liner of hydrogen compression tanks with a polyamide 6, and we are working also quite hard on that, and we see big growth potential also in that area.
Right. So what you're saying is Lanxess is betting on hydrogen as well, and obviously, storage is one issue, and clearly that's one area you're focusing on with materials, to make it a little bit more, let's say, feasible.
We believe in both, and I mean for trucks, for buses, for commercial vehicles, hydrogen is definitely a viable solution. And if you look into short distance traffic within cities, electrical cars are the better option. So it's not either or. It's both basically. Yeah.
Right. And just turning to the charging infrastructure industry, of course, this again is one issue in certain markets. The infrastructure sometimes doesn't keep pace with the growth in EVs. What kind of contribution is Lanxess, giving in the charging industry, for example?
A lot. I mean, the second largest pillar. Oops. Hold on a second.
Yeah, sure.
Wait, I have something here. Oh, sorry. Okay. So we have been also supplying solutions to the E&E industry for more than 20, 30 years. And from that knowledge, we had a kind of kickstart into the charging infrastructure. So we can provide solutions for charging couplers. We can provide solutions for charging stations, for wall boxes, for wireless charging. So many solutions, from just housings, inlets and outlets for AC, DC charging, sensors, circuit breakers, covers, housing, structural parts. There is a whole bunch of solutions for the infrastructure, all made from engineering plastics. So this is, if we talk about electromobility, we basically see three areas of growth. This is the powertrain, the charging infrastructure, and finally everything what is related to autonomous driving. Yeah, sensors and radar sensors, LiDAR sensors, ultrasonic sensors. So these are the big three areas where we see significant growth potential.
And we're running out of time, Dr. Tukmensky, but before we wrap up, I just wanted your overview on, let's say, a global picture. Which do you think are the high growth markets globally? And looking at your experiences from China, drawing parallels with other Asian markets and India, if you can again just give us a broad base as to which markets do you really see a lot of action. And yes, we know Europe, China, US, the kind of traditional markets are there, but are there any other pockets you see a lot of potential?
Well, I see big potential for India. I mean, if I look at cities like Mumbai, like Delhi, yeah, the pollution you have. I think there's nothing better you can do just changing from combustion engines to electrical vehicles, just to improve life in these mega cities. So yes, absolutely. I'm a strong believer, and I think there are 1,000 good reasons to switch to electromobility. Even though maybe this is in Germany the case, this is in China the case, or all over Europe the case, and it's also in India the case. I mean, of course, to make mobility climate neutral, you also have to provide renewable energies, but this comes later. Yeah. So in the beginning, I think it's also a lot about improving the local climate, the local emissions, and I think that is something which is of big interest for cities in India.
No, absolutely. I think, to try and eliminate what we call the tailpipe emission at the street level, obviously really improves the quality of life. But Dr. Clancy, thanks so much for talking to us. You've given us a wonderful overview, and it's good to know that Lanxess is well placed, can react quickly to the fast changes in the EV industry. The fact that you're also looking at hydrogen as really one big potential, which we think in India is really, just given the geography and the logistics of running EVs, hydrogen is a good option. And once again, really thanks so much for that overview. And we look forward to seeing Lanxess growing in India as well. And with that, I'd like to hand it back over to Mayank for the rest of the session. Thank you once again, Dr. Tuklensky.
Thank you very much. And we are, of course, ready to cooperate with partners, to team up with partners in India. Anytime.
Thank you. Look forward to that.
Thank you. Thank you, Dr. Tuklensky. Thank you, Hormus, for that dialogue with some very incisive comments. And you've given a very good overview about the changing dynamics in the mobility ecosystem and how we need to focus not just on EVs, but also how hydrogen is going to play a key role going forward. So with that, I would now request Dr. Tuklensky to just stay back for taking us through his technical presentation that's lined up right now on the topic leading innovation and engineering services from Lanxess for a cost-effective electric mobility. Dr. Tuklensky, over to you, please.
Okay, thank you. Can someone, because I think the line is not fast enough, can someone just bring my slides on the screen? Sure. And then I would ask you just to. Perfect.
Yes, we've just made your presentation live. And before we begin, Dr. Tuklensky, I would just like to give a note here to our attendees that whatever questions they have, they can just type them out in the Q&A box. And after for the presentation, I would happily take them with the Dr. Tuklensky.
Okay, good. So again, good morning from my side again. Yeah, what I would like to share with you in the next 20 to 30 minutes is first of all our view on. Yeah, please go to the next slide. So our view on solutions for new mobility, what is changing with the transition from the combustion engine to the electrical powertrain. I will show you an overview of where we see in the electrical powertrain applications for engineering plastics, but I will also touch applications which are related to traditional, like in the traditional area of polymers, like lightweight. So these two topics will be touched in my presentation. Later on, my colleague Jürgen will go more into a deep dive. And what is also important, what I would like to emphasize is what kind of services do we offer from Lanxess, global services, but also regional services. And this will be discussed in the second part of my presentation. Next slide, please. So what you see on this slide is what we have discussed earlier in the interview. This is basically a powertrain scenario, and you see, if you look at this scenario, if you look at the red bars, this was our view in 2018 on how battery electric vehicles would penetrate over time. And the other bars in black, gray, and light gray, they indicate an estimate from Boston Consulting Group for the three regions, Americas, Europe, and China. And you see the difference between our view in 2018 and that latest view from Boston Consulting Group. Especially if you look at 2030, there is big difference, and also 2035. So 4 years back, we underestimated roughly by 3 times the penetration of the powertrain. And this is basically because policy has changed. The new Green Deal kicks in. The Biden administration is pushing electrification. And also the OEMs itself, the big OEMs, they are also completely switching their strategy from combustion engines to electrical vehicles. And what does that mean? If we go on the next page, please. What does that mean for the industry? I hope you can read it. This looks a little bit smaller, but I would try to explain what is behind this. If you look at the at this image on the left-hand side, this is the market size of mobility solutions in 2019 on the left-hand side, and in 2030 on the right-hand side. And you see the market itself will grow from 216 to 230 billion euro. And now what you see with the powertrain shift is that we have so-called sunset commodities. These are applications like in the engine compartment, in the transmission area. So these kind of applications, they will more and more fade away. Then we have stable components. So everything what is related to lightweight structural parts, for instance, this is what you always need. You always need also wheels and seats. So these are more or less stable components. And then we have the growing components, which is like the battery management systems, sensors for autonomous driving. So everything what is related to new mobility. And in numbers, this means these growing components, they will triple by 2030 in terms of volume. Even stable components, they will grow by 18%. In sunset commodities, they will shrink. So everything what is under the hood will sooner or later disappear, or at least will become significantly smaller. But looking at these growing components and also at the stable components, engineering plastics, they play an essential role. Next page, please. This is again what we had in our interview before. These are just some voices from the European industry to illustrate what is ongoing now these days. If you look on the left-hand side, these are voices from OEMs highlighting the transformation. The Ford CEO is confident that the electric vehicle strategy won't cede. Mercedes even stopped to develop plug-in hybrids, so they completely go into battery electric vehicles. And Renault is setting up plans to cut 2,000 jobs in France due to the EV transition. So there's a lot going on the OEM side, but also if you look on the right-hand side, supplier transformation. MAN and Hummel, very strong in the under-the-hood business. They are shutting down their production facilities in the headquarters. Yeah. And then we see that Faurecia just recently acquired Heller to become a big player in the electromobility area, including hydrogen. So big shift, big transition, maybe also even disruption is going on in the automotive industry. Next page, please. So what does that mean? In the long term, this is a consolidation will occur. The transition goes much faster than expected. And we see that in battery electric vehicles, the value chain structure is completely different. We have significantly less parts in an electrical car. So all in all, we expect, also experts expect, and this is a poll from a magazine in Germany, Automobilproduktion. They expect powertrain segment. So pretty clear and strong statement. Next page, please. So now I would like to I mean, for time reasons, I want to focus just on a few applications. Jürgen will later on pick up some of these applications and will go more into a deep dive. Let's look into opportunities for engineering plastics in the electrical powertrain. If we go to the next page, please. Where do we see the main areas of applications for engineering plastics? So definitely everything around the battery system, battery housing. This is something full plastic battery housing, massive market. If plastics, I mean, this is still right now in the phase of feasibility, technical and commercial feasibility analysis. But if full plastic battery housings will establish in the market, then you have easily 20, 30, or even 40 kg per vehicle just for the battery housing. This is a massive volume. Structural components in a high voltage battery, bus bars, bus bar holders, cell frames and spacers, and also, of course, equipment to do thermal management, to remove heat from charging and discharging batteries. So battery system, from my understanding, brings the biggest volume for engineering plastics. Jürgen will touch this later in his presentation. Then we mentioned everything what is related to charging in the vehicle, but also the charging infrastructure, of course. Charging inlets and outlets, onboard chargers, inductive chargers. Connectors, also very, very big and growing area. High voltage connectors in orange, 48 voltage connectors, standard connectors. They all have to be flame retardant. So you need, first of all, good design of the connectors. You need excellent electrical properties of the material, electrical insulation, but also orange. Auxiliary equipment like cooling pumps, air compressors, PTC heaters. This is also a nice playground for engineering plastics. And of course, everything what is related to control units, electric control units, power electronics, but also actuators. Yeah, so many applications, new applications for engineering plastics. And what is important, of course, you need the right material. And if we go on the next page, what are the material requirements? This is just a small selection of material requirements, but for our understanding, the very most important properties. Flame retardancy. Whenever you're dealing with high voltage applications, it is an OEM requirement to offer flame retardant material. V0 is a strong requirement.
It's 11 o'clock.
What does that mean? 11 o'clock? Can you go back one slide? Okay, thank you. Orange in the electrical insulation when it comes to connectors, just to avoid an electrical short circuit. Thermal conductivity, when you're somewhere in a connector or in a battery environment, to remove the energy, the heat, which is coming from charging or discharging. Very important material requirement. Hydrolysis resistance, especially when we talk about PBT in areas of control units. You need to stabilize the PBT at higher temperatures. And laser transparency, whenever it comes to sensors for autonomous driving, mass production requires laser welding. And for that kind of processing, you need laser transparent material. So these are 5 material requirements we can offer solutions for. Next slide, please. And if we look at at the applications, this is, and if you look on the left-hand side, you have applications, traditional applications under the hood, and applications now in e-mobility. And if we convert that into plastics demand per vehicle, you see on the right-hand side, for a combustion engine of a standard size, you need roughly 10 kg of engineering plastics. If we look at plug-ins or battery electric vehicles, we need more. And if we just estimated 14, and if we take battery housings into account, we can easily reach 30 or even 40 kg per vehicle. So there is a big volume, additional volume coming just into play when we talk about electric mobility. So this is very good news, and we are very excited about this growth potential. Next page, please. But also, coming back to this slide again, we also see structural components, structural parts will still play an important role. And from that, we can easily derive, next page, please, that lightweight design is still an important thing. I mean, lightweight makes electrical vehicle lighter, and of course, this is good when you look at the range, the driving range of electric vehicles. What is lightweight? If you go to the next page, is more or less the DNA of LANXESS. We have experienced experience in lightweight design for more than 3 decades. We started in the 1990s with plastic metal hybrid technology. This is basically technology how to combine the best of both materials in order to achieve lightweight solutions, and 100 millions of front ends in today's cars have been equipped with solution. Then 10 years later, we developed high modulus compounds, so compounds with a high glass fiber loading. 10 years later, we came across with the first full plastic brake pedal, a combination of composite material and engineering plastics. And now we have launched just recently hollow profile hybrid technology. This is basically the combination of a hollow profile with engineering plastics. And if we go to the next page, I would like to show you a video. I hope this works now technically. And that video somehow gives you an idea about, can you play this video? Obviously not. Too bad. Maybe we can provide this later on. So this video basically was supposed to show how we functionalize hollow profiles with glass fiber reinforced polyamides in order to achieve very stiff and strong structures, for instance, for cross-car beams. And if you look at this photo and this picture, you see cross-car beams, they are mainly made out of steel, aluminum, or magnesium. And our solution is basically a combination of a hollow profile, so a tube, with engineering plastics. And the beauty of that one is that you can very easily functionalize cross-car beams. And this is a lot easier in processing. You have significantly less processing steps, and you have much bigger freedom when it comes to tolerances. Very bad that we cannot see the video now. So then please go to the next page. So we have done a concept study to compare basically cross-car beams made or manufactured with this hollow profile hybrid technology in comparison to industry benchmark. And what we found is basically that we can achieve a very, very strong mechanical performance and just at the same time reducing weight and also reducing costs. So we have achieved 20 to 30% of weight reduction while maintaining the same torsional strength and stiffness. In addition to that, we have a simple processing and pretty easy tolerance management with that kind of technology, because it's a lot easier just to overmold rather than welding that kind of cross-cut beam structure. And in addition to that, you can use standard injection molding machines, so you don't need special equipment. In other words, functionalization of structural parts with engineering plastics is doable and feasible and also cost effective with that kind of technology. Okay, coming to the second part. How do we run projects? How do we develop products and applications across the globe? I would like to show you on a few slides how this is being done. Next slide, please. This is an overview of our R&D community worldwide. We have the R&D headquarters in Dormagen. This is between Düsseldorf and Köln, so western part of Germany. And this is where we have also our product development, the application development, and our CAE, advanced CAE department. In China, we have a big material testing center. In Hong Kong, we have our application development center for part testing. And we also have a very, very strong CAE department. So the colleagues in Hong Kong, they have a very, very close interaction, of course, with the colleagues in Germany. And out of Hong Kong, all customers in Asia, or the services to our customers in Asia will be provided. The same concept also applies to our application development in Pittsburgh. They are covering North America. We have an application development in Sao Paulo. They are covering South America. In addition to that, what you see in blue, this is Tepex. This is our subsidiary for composite material. And all in all, there's a pretty close interaction in the entire technical community. We have 150 people worldwide providing innovation and tech service. Next page. So as I mentioned earlier, all the material requirements, for instance, for electric mobility, flame retardancy, thermal conductivity, hydrolysis resistance, all these products are being developed in Dormagen. We have a group of chemists. They are working on improving on a daily basis our compounds, our compound portfolio, to achieve leading flame retardancies, to improve the processing behavior, to improve mechanical properties, or to improve the aging performance, or maybe all the combination of everything. And of course, also in order to meet customer requirements. Next page, please. And of course, polymer development also needs good polymer testing. We have testing center, a high-end analytical testing center in Germany as well. We are covering more than 70 tests according to DIN, ISO, ASTM standards. We have specific tests when it comes to heat aging, weatherability, media resistance, flammability, and so on. So this is really top-notch lab for material tests and chemical analysis. Next page. This is very important for you guys in India. We have an extremely strong and well-equipped application and development and testing center in Hong Kong, in the Hong Kong Science Park. The colleagues there, they provide CAE services including basically complete solutions from rheological and mechanical analysis, as well as when it comes to design, developing these design concepts, design strategies. They also have an existing part in the very big part testing facilities where you can run vibration or so-called shaker tests, where you can do burst and pressure pulsation tests. And of course, they are also very, very flexible when it comes to run customer testing and to provide test results on specific customer requirements. So all in all, a very, very experienced and dedicated team. 2 slides on sustainability. Sustainability will become the license to operate. This is our firm belief. Without sustainable solutions, without sustainability in your production processes, in the long run, chemical companies cannot survive. So that's why, next page, please. We are working basically on 2 things. First of all, becoming climate neutral by 2040, and second, becoming more and more circular. Just to give you a number, by the end of last year, already 5% of our portfolio of all the raw materials we are using has been circular, and this is further growing. And as I mentioned earlier, we will never compromise on performance. Whenever we talk about sustainable products, they are prime quality. Okay, and this brings me to my last page. For you, takeaway message. Electromobility will lead to fundamental changes in our industry, and rather sooner than later. But we also believe electromobility is a massive opportunity to grow. If you develop the right products and the right solutions. And the best, of course, would be to do it with a partner. And that's why we would like to invite you to embrace these growth opportunities in electromobility in India with LANXESS. Well, and this brings me to the end of my presentation. Thank you very much for giving me the opportunity to share our thoughts and to attend this session and having the option to talk here.
Wonderful. Thank you very much, Dr. Tuklinski. That was a really detailed presentation. And we've already started seeing questions pouring in for you. So even though we have very little time left, but I think we'll be able to squeeze a couple of them. So there's a question which has come, and the question is, what is your opinion on multi-speed transmission for EVs like 2-speed or 3-speed for enhancing range on small capacity motor setups?
Well, we, as I mentioned earlier, we strongly believe that in India, 2-wheelers and 3-wheelers, that will be somehow the entry platform, the entry concept in the electric vehicle. And range is of course always a big thing. And from that point of view, yes, this is a valid option, definitely. Yeah.
Sure. One more question is coming from India, from Mr. Prasad Sharma. He wants to understand, how does LANXESS foresee the polymer prices of PA66 and PA6 evolving in the next year, that is 2022?
Well,
I would like to take this question.
Okay.
Sure, Dr. Mr. Khare,
Okay.
please. Yeah.
I think whatever is happening in PS66 and PS6 area in last couple of years, I think this is a very valid question. Especially PS66 availability and prices have got completely haywire, and nobody has got any control over it. Basically, this is happening mainly because of the severe shortage of adiponitrile, which is input raw material in a backward value chain of PS66. And then if you really go into details, we believe that availability of adiponitrile is not going to improve, because whatever we know, there is no substantial increase in the capacities of adiponitrile for next 2 years. So, I mean, whatever as per our information, one capacity addition is going to happen in China probably in 2024 if it is not delayed. And that's the reason why, you know, my view is that shortages in PS66 area are going to continue. And then this, whatever is happening in PS66 area is happening second time in last 3 years. And then the consequence is that, you know, prices have completely skyrocketed. That I believe is going to continue. There might be some small relief here and there depending on the demand. Because if I assume the demand is going to maintain as it is or it is going to increase, I think availability of PS66 and prices of PS66 will be in a concern area. However, in PS6, there is no such concern. I think PS6 prices also are quite okay, not actually increasing the way PS6 has increased. PS6 prices also are increasing, but they are steadily increasing. I would not say they are vertically increasing. And then availability is not an issue as far as PS6 is concerned. So that is the reason why, you know, we recommend to our customers that there are very few application areas where you really need PS66. And then barring those application areas, you can virtually convert everything that PS66 makes into PS6. And we have already we have success stories in this area. We have converted many applications. Just to name few, NVH dampers we have converted from PS66 to PS6. We have converted breather plate from PS66 to PS6. We have converted engine mount from PS66 to PS6. So I think we help our customers in this area, and then I would say let us know why you are using PS66, or probably we can evaluate that for you, and then we can jointly work with the customers if they want to convert from PS66 to PS6. And that is the I would say there is a pull for this initiative today in the market, and we are always there to support our customers.
Sure. Thank you so much, Mr. Khare. I think, Mr. Prasad, you would have got your answer. And like Mr. Khare has mentioned, you know, you can get in touch with Lanxess to collaboratively, jointly work on your requirements in terms of the materials that you've, the query that you've shared. With that, I think let's do a transition into the next panel discussion. And for that, I would like to invite Mr. Pankaj Khare. He's already here. He's the business unit head and head of sales and marketing, high performance materials at Lanxess India. I would like to give a quick introduction. Mr. Pankaj has obtained a degree in engineering in plastics and mechanical and PGDBM from Narsi Monji Institute of Management Studies from Mumbai. He has over 30 years of experience in the industry of engineering plastics. Prior to joining Lanxess, his experience has mostly been in multinational companies. He's currently working in the high performance materials business at Lanxess for over 9 years. Then we have Mr. Jorgen Zelig, Head of Application Development, Lanxess, Hong Kong. Mr. Jorgen has studied material science and is a major in polymer sciences from Erlangen, Germany. After studying polymer sciences and several years in project management in the automotive supplier industry, Jorgen joined Lanxess High Performance Materials in 2006. Since 2012, he is responsible for application development at Lanxess, Hong Kong for the APAC region, with an increasing focus on electric mobility. A very warm welcome to you, gentlemen. And let's proceed with the panel discussion. And I would like to get a quick comment from each of you regarding how do you see the dynamics changing in the mobility ecosystem? We are seeing a push or a pull rather towards electrification now. So what is your take on it and the growth outlook that you see? Mr. Khare, would you like to go ahead first?
Yeah, sure. I think in India, there is a lot of enthusiasm as regards to e-mobility is concerned. And then we all have seen that in last 2 days, and this is a third day today. A lot of action happening already. However, I would say in India, it is just kicking off. I mean, two-wheeler industry is going to have quicker transition from petrol to electric mobility. However, if I go by Mr. Varun Dubey yesterday, he mentioned that only 15% of Indian population has got the vehicles, and that much is the scope for e-mobility to shift from engines to EV vehicles. I think going forward, I see within a couple of years, a lot of shift will happen in two-wheeler area, and then probably four-wheelers, cars will take some more time, but anyway, it will happen. For sure, it will happen.
Sure. Jorgen, coming to you, your thoughts, please.
Yeah, when we take a global look, as Dr. Tuplensky also pointed out, in the past years, we've seen the momentum for electric mobility really picking up steam very, very quickly. When we go a little bit further back, 10 years back, that was a time when the Tesla Roadster was already introduced. And but by that time, it was still slightly belittled, and nobody or hardly anyone took it very seriously. And that has changed in dramatic fashion in the past years. I think mainly driven by government regulation for sure, but also by steeply declining battery prices. So we see a very strong momentum in Europe, in Asia, in countries like China and Korea. So I think it is just a matter of time until it really, becomes a very broad movement across Asia and also in India.
Sure. You mentioned Asia and India. So if I may understand, what are the avenues of innovation with respect to e-mobility that you see specifically in India? Because, India is a very cost-conscious market. So at the moment, we are seeing an offtake more in the two-wheeler and the commercial three-wheeler segment compared to the passenger cars. So what is your assessment of the scenario?
From our perspective as a material engineering plastics producer and solution provider, of course, we look into the applications very precisely. And maybe I'll give you a little outline on what we've been observing in the past couple of years in other countries and what we expect to happen everywhere. So what we've seen is that, the first applications to come in engineering plastics were simply those that absolutely needed engineering plastics for electrical insulation purposes, like high voltage connectors, charging inlets, charging connectors, and so on. So that happened first. And what we see now increasingly coming is actually that engineering plastics venture into other applications, into battery components, into battery module components, into 48-volt battery housings. And then we're back to that almost classic story of metal replacement. So this is also happening now. And from the material point of view, what does it mean eventually for us? What we've seen is a very quick uptake of flame retardant materials by the industry. This is really the major change that we've seen. And with that spread of engineering plastics into more and more applications, we see a certain need for diversification of the materials. So customers expect us to actually tailor make or to optimize the grades for the specific application, not just take over the E&E quality of the grade, but adjust it to the application. Now, for example, to give you an example, when we go into battery module housings, the parts are usually not that small and not that super thin. So do we need then UL V0 at 0.4 millimeters? No, we do not need that. But what we do need is better flowability, better surface appearance, and so there's a need to adjust these E&E quality grades. So this is the latest trend that we see. definitely a spread of engineering plastics into more and more applications in the entire electric powertrain.
Sure. Mr. Khare, before I come to you, I'd like to stick with Jorgen for a moment more. Jorgen, you've touched upon, these materials, and we've got a question in the comment box. So I would like to take it up right away. There's a gentleman who wants to understand that where are we in terms of technology to reduce the weight of the motor by using metal integrated plastics without affecting the EMF generated?
Mm-hmm. Okay, so if we go into the motor, this is certainly a pretty challenging application. And so far, we haven't seen a metal to plastic replacement happening successfully until now. There are projects already happening, but it is certainly a pretty challenging field by many standards. So if you ask me which application to take on for weight and cost reduction, it would probably not be the motor. There are components inside, yes, that can be replaced. But then we take on the major housing. That is rather challenging. Tolerances, for example, the heat management. So that is, I would say, not the first choice. If you ask me what to go for, then I would definitely aim for the encapsulations of the battery modules, and also the main battery housing, as we heard before from Dr. Tuchlensky. There are already projects happening. We are already working on converting that major piece of metal into plastics. Also a pretty big challenge, but here we see actually a good approach. And so you see, the answer to that question is a bit complicated, and we really have to look into this. But that brings me also to an important point. We really have to work in the concepts. And this is also where, we don't stop with the material. We don't say, take this or take that, but we go into concept development together with a customer. Can only invite attendees and their companies work with us. Let's see how far we can get. We are working indeed in the motor segment on a replacement. Yes, so I can only say invite you to join us for joint development.
Wonderful. Mr. Khare, Jorgen just mentioned about these different areas of VAV or innovations within the vehicle, taking the battery, for example. But I want to get a broad understanding from you, with respect to the Indian market. So what are the major avenues of innovation that you see? Are we looking more at the two-wheelers or the four-wheelers? So if you can give your perspective there.
I think it's not a question of two-wheelers or four-wheelers. As far as innovations as a raw material supplier or a supplier of performance polymers, if you talk about, I think on one area, we have a fantastic team to formulate newer and newer grades which are required by e-mobility tier ones and e-mobility OEMs. Just to take an example, I think if we talk about a very recent formulation that we have come up with, in PBT area we have got a fantastic grade, and I believe not many in the field are having those type of very specialty grades. In PBT area, we have got hydrolysis resistant and FR grade, which is very unique as such. And then we have got some grades like this. However, I strongly believe that one area is that to formulate the grades which are suitable for applications in e-mobility, but at the same time, I think it is also important to help our tier ones or help the actual users of those materials to really put those grades into actual use commercially. So actually, Lanxess plays a very important role, and as I think I have briefed it before as well. From the designing stage, from designing to material selection to prototyping to tooling and to processing and to testing validation, I think Lanxess helps the customers a lot in the entire development cycle, and that is actually the value addition that we offer to our tier ones. And then, we also have got our domain experts in various fields. For example, I would like to give an example. when we enabled our first polyamide PS6 blow molded monolayer fuel tank for two-wheelers. We had called our blow molding expert from Germany to support the tier one to enable him to get the blow molded component. Or in case of automotive lighting area, there is a direct metallization area that we supply the material to. And then we had called our expert from Singapore to support the tier one and to ensure that the rejections go down drastically. So I think this knowledge actually is very important, and that's what actually the value that we see we can add to the whole development cycle.
Right. So clearly a very customer-centric approach from Lanxess to support the tier ones or the customers, in developing new products or these these materials.
Yeah.
I mean, clearly, Mr. Khare, with e-mobility, there's a great opportunity for you going ahead. But I want to also touch upon the challenges that electrification of the powertrain brings. Does that also spell a caution for the ICE-related components that you're already dealing with?
Jürgen, would you like to take this?
Yeah, of course I can take that. Yeah, I mean, of course you're right. If the scenarios develop very progressively, then we will see classic components of the ICE powertrain disappearing. There's definitely a fact. Yeah, as we heard earlier, also from Dr. Tugolensky, we also evaluated that scenario. Is that a risk or is it rather an opportunity? And we came to realize that it's actually a bigger opportunity even. There are a lot of new applications coming up with the electrification of the powertrain that need also very strong engineering plastics. And we are already in these applications. We're already developing them together with our customers. So we see here actually a very strong opportunity. And I think we are well prepared also for the changes. So what we've been seeing in the past couple of years is that, elements of the E&D industry now entered the automotive industry, predominantly flame retardancy. This is the one biggest new topic. The automotive industry before actually was very reluctant to introducing flame retardant materials, even for the electrical system. There were fires, there were really bad incidents, but the automotive industry did not embrace flame retardant materials. And with the high voltage, that embrace came very fast. And so we saw that is one of the key properties coming in. And suddenly there was a demand for flame retardant materials. Fortunately, with our history in providing also materials for the E&D industry, we had those materials ready, a large portfolio, very wide portfolio of halogenated and halogen-free materials. And most importantly, also with listings according to the bodies like the UL and the VDE. So it was very important that we started that process years ago, because it takes many years to have all these listings. So we're well prepared with this. And so this was, I would say, the first step, taking materials, offering them from our existing portfolio. And I mentioned it before, what we're doing now, what we see now is we adjust those grades to the very specific needs of the automotive environment. So here I have a few examples. We heard also before, a very simple sounding example, the color orange. Now, in the E&D industry, we have all kinds of colors, but we do not have the color in combination with a long-term heat aging requirement. This is something we have in the electric powertrain because of the fast charging requirement. And also, sometimes we still have combustion engines in an electrified powertrain in a hybrid car, so it can still get hot. So we must make sure this color is recognizable as orange over its lifetime. So we needed to do this all new over again. Another example is the whole trend of overmolded metal inserts, bus bars, for example, inside the battery and beyond. So this is a rather new thing. And if you just go here with flame retardant material, flame retardant PBT, for example, you may have a problem because during the heat shock tests, we will see tendency to cracks. This is well known. And so also here we need to adjust the materials. We need to tweak the materials to fit in, to match with the new requirements. So you see, we're not done yet, but we are in the process of doing this adjustment you can say there's a fusion of two worlds, automotive and E&E world. This is in process, and we're just advancing together with the industry here.
Right. That's a wonderful insight, Jorgen, about fire retardant materials, and especially from a layman's perspective about modifying the need for modifying materials, especially if you want to offer some unique colors in EVs as well as hybrid cars. So that's a wonderful insight. I want to understand from you. You mentioned that the industry did not adopt these the fire retardant materials for a long time. It's only with EVs that you've started seeing an accelerated adoption. Yes. So that does bring a question about, are these materials cost effective enough? So what is being done to make these materials more and more cost effective?
Yeah, costs, of course, are always a topic. Flame retardant materials are only used because they have to be used. Otherwise, everyone would try to avoid them. Yeah, because, mechanics don't get better, costs also don't get better. But we have seen a certain, I would say, drive to cost efficiency earlier, not just from the automotive industry, but also from a consumer electronics industry, and also even classic industry in E&Es. So this is already ongoing. And then, of course, there is a certain margin as I said before, we can adjust those materials to the actual need of the application. So there's some room to play and to make materials also as cost efficient as possible. But eventually, we cannot compromise on the key properties. And if we have to fulfill, UL 94 V0 stable or a glow wire requirement, then we have to do that. And there is no bargaining with the UL or with the VDE. So this is eventually, it's then up to the OEMs to decide really, do they need maximum flame retardancy or do they not? But it seems very clearly with the high voltage, they do need that. Yeah.
Right. I would take that.
I mean, in this area.
Yes, please.
In this area, I would say performance is basically what is looked at. And then, flame retardancy also depends a lot on thickness of the component. And then, you also need to really keep that in mind, what actually is the thickness of the component, and then decide the material. But if you talk about non-fire retardant materials and fire retardant materials, I think there is no comparison as far as price is concerned. I mean, the OEMs and tier ones have to decide what they want. And really, yes, I would say fire retardant materials are not that competitive on price as compared to the non-fire retardant materials.
Right. But talking generally, Mr. Khare, India is a very cost-sensitive market, that. So if you talk about from an India perspective, so how are plastic raw material innovations connected with whatever is happening in the EV space in India?
Actually speaking, I mean, raw material innovations that we talk about, as I told you before, have got something to do with material selection, and then having the right material for that application. I mean, we have got more than 300 grades already, and we keep on adding new and new grades to our portfolio. Especially for EV, also, as Jorgen has already said, we have got a few grades which are dedicatedly being offered to EV manufacturers for their components. So I think newer and newer grades will keep on being put on platter. The OEMs and the tier ones have to decide, what exactly they want.
Right.
And then Lanxess is always there to support their application requirements, and we have got fantastic capability to really come up with newer and newer products. And also, I think if we talk about Lanxess as a performance polymers supplier, I think we have got already got good success stories somewhere in the world. And then if you talk about application like charging gun, I mean, we have done already somewhere in the world, and then tier ones in India have to just come to us and tell us their requirements. There are possibilities that we will be able to choose from our portfolio that we are what we're using in Europe or what we're using in the US, and then try to multiply that in India. That quite is a possibility. And then in case of Lanxess, somebody like Lanxess, I think I would like to say that we have got a global approach to the product quality and availability, and a local approach to manufacturing and technical support. What it means is basically, all our formulations are done in Germany, and then whatever goes inside also is decided by the team of qualified people who work on recipes. And all our compounding plants all across the world use the same raw materials all over the world, and we are not allowed to use anything other than the specified raw materials. That is the reason why any grade, particular grade, if you pick up from our German plant and if you pick up from Jagadia in India plant, you will find very, very similar properties, and that also is one of the reasons why we can just pick up from our portfolio and apply to the different region altogether. So this is the advantage that working with a global company like us, and then of course technical support plays a very important role here as well.
Right.
And as Jürgen said, our knowledge of automotive, we have been working in automotive for more than 90 years now, and then in the E&E sector for 20-30 years. Right. So knowledge is the key, and that is on the platter from our team. So this is what we offer to our customers.
So adopting a very global approach to offer the best of the quality as well as to meet the cost targets for the Indian market.
Absolutely.
Right. With that, Mr. Khare, you mentioned about charging and the charging guns and all. I want to touch upon with that the battery, which is the most critical component of an EV. So if you can shed some light on the innovations that Lanxess is doing on the battery front, and if you can give me an India perspective on this.
Jürgen?
Yes. I would suggest to hang on and until I get into my presentation, because I have the battery really on my list definitely as a top application.
Right.
But yes, there's a couple of applications, quite many. The battery module housings, the bus bars, overmolded bus bars, high voltage connectors, battery management system. A whole lot, and very different materials used and newly developed, and also quite some concept work done. Yeah, more in the presentation, I would say.
We'll definitely wait for the presentation to get all the details on that front. But Jürgen, I want to also understand, sustainability. Like with EVs, we are essentially talking about sustainability, sustainable environment and sustainable mobility. So how are you addressing the sustainability question when it comes to the performance materials, in general, the materials as well as the batteries as well? Yeah.
Okay. I have to pick up the points of Dr. Trublensky earlier. Of course, as a company, we are definitely committed to ecological sustainability and to the European Green Deal, just to repeat this. And we're even going further, so let me say that. And we will, the European Green Deal sees a net emissions goal by 2050. We aim to have this by 2040 by cutting our own emissions of our own production facilities. So we're even more bullish on this. And yes, when it comes to the materials, we definitely aim to increase the range of materials that use recycled feedstock. So that is the cornerstone of our strategy, I can say. And so that applies then, of course, also to materials in the battery segment. There's no difference. Of course, our materials, to speak generally, can be recycled, can be reground and reused. So there is, I think, our materials are probably the smaller challenge when it comes to the battery. So when we see these huge pieces of battery, I think it is that the focus is definitely on the actual cells and the insides of the cells, cathodes, anodes, electrolytes. So that would be another major focus. But that is a field I cannot talk for, because this is then a different territory, not our territory.
Right. Jorgen, since you are a specialist in materials, so there's another question that I want to take here. It's from Mr. Sanket from India. He wants to understand which polymer demand will rise in the EV segment in future. Is it going to be amorphous or crystalline polymers?
Well, we produce semi-crystalline materials, and I can tell you that when we started seriously going into electric mobility some 5 years back, we would have maybe not predicted such a steep increase in demand. So we can say that the semi-crystalline materials definitely are very much in demand for the new applications, simply because of the very complex mix of requirements that we see here. We see the demand for flame retardancy. We see electrical properties high in demand, like as high CTI. We see still some temperature demands, especially for hybrid vehicles, but also for components in the related or connected to the high-speed charging. So there is still heat to be taken out. And we see also chemical requirements. Even lithium electrolyte resistance is asked for inside the battery. And this is particularly also something that the semi-crystalline products can handle extremely well. Or take a charging gun. So the part you use to charge your car. This is exposed to all kinds of chemicals, cleansing agents and the likes. And that works very well with the semi-crystalline material. So yes, there's also amorphous materials used. But my impression is definitely that the semi-crystalline products can work here extremely well in this environment. Oh.
I'm sorry, I was on mute. Yeah. So I was saying we've completely run out of time, but as we come to the end of our discussion, I would just like to get a quick comment from both of you, and understand how LANXESS plans to replicate the global success that it has represented in the EV space in India. Mr. Khare, would you like to go first?
Okay, I think as far as global success replication is concerned, I mean, as I told you before, it's a question of how we really replicate our experience outside India. And then, if our customers want to buy the global quality materials, it is definitely available in India. We have got this global standards all across the world, which we follow in India as well. And I already explained to you the global approach that we have, and then local approach for manufacturing, because we have a manufacturing facility in India and all other continents as well. I think it's only a question of transferring the knowledge that we have, and then we work very, very closely. And as you also will be seeing this, Dr. Axel is participating today from Germany, and then Jorgen is participating from Hong Kong. So I think we have a EV team that works continuously on a real-time basis, and then we coordinate between each other very, very actively, so that knowledge transfer happens very seamlessly within LANXESS. And then that helps us, to transfer that knowledge which we have generated somewhere in the world to transfer to India, and then comes handy for our customers in India. So we are there for our Indian customers. We are there for our Indian tier ones and OEMs. Just a question of getting in touch with us, and we will definitely support in all the areas that they want us to contribute.
Last words from you, Jorgen. I mean, you had the APAC region. So what's your plan to replicate the success that you've seen, in Europe or the developed economies in India?
Yeah, not too much to add from my side. I fully agree. And most important is really to get into the collaboration with the customer at an early stage, so that we can really also give some input for the design. We can run all the simulations and part testing, so that we can give really the full service, and this is an added value to our materials, so we don't charge for these services. So get us involved as quickly as possible, as early as possible, and we'd be glad to do this replication of these stories in India.
Wonderful, wonderful. With that, I would like to thank you, both of you gentlemen, for taking out the time and sharing your thoughts on this panel discussion.
Thank you, Mayank. Pleasure being here.
And for the attendees, we do have Jorgen with us for some more time. And after the next panel discussion, he'll be here to give us his technical presentation. So I think we'll have more details on materials and the innovations that Lanxess is working on regarding different components for EVs. With that, it's time for the third panel discussion on the topic innovations in electric mobility space. And we have a very eminent panel. I would like to extend a very warm welcome to Mr. Sanjay Kapoor, President, Automotive Components Manufacturers Association of India, as well as Chairman Sona Comstar, and Dr. Axel Tuklinski, Head of Global Product and Application Development, High Performance Materials Business, Lanxess. I would again like to invite Mr. Hormuz Sorabji, Editor, Autocar India, for moderating this panel discussion. Over to you, Hormuz.
Thanks very much, Mayank, and hello, everyone, and welcome to our next panel, which is on innovations and opportunities in the EV space. And for this panel, we have with us key suppliers to the EV ecosystem to talk to us about future technologies, opportunities in the EV space. And it's my pleasure to invite Sanjay Kapoor, Chairman of Comstar, to this panel. Now, for many of you all in the component industry, Mr. Kapoor needs no introduction. He's had over 21 years of experience in the automotive industry. He was the managing director of Sono Koya Steering and has served as director on various automotive companies. He's currently the president of ACMA, and so he represents the Indian component industry. Our other panelist is Dr. Axel Tuklinski, who Mayank has just introduced. We've had a very interesting and insightful discussion earlier on in the day. And Dr. Tuklinski is a veteran in the chemical industry and holds a PhD in chemical engineering. So, gentlemen, thank you for joining us. And since both of you really represent the supplier side, I would like to kick off this session by touching upon what possibly is a big issue in the Indian automotive industry right now in the EV space, is that the supply chain is still quite underdeveloped. The whole challenge of building a supply chain in India, and are we still very subscale, especially in the four-wheeler segment? That's one area we possibly are. And with that, I'd like to start with Mr. Kapoor. Mr. Kapoor, your thoughts on the whole supply chain challenges, opportunities.
Thanks, Hormuz. Thanks for having me here. It's interesting. It's an interesting discussion because at interesting times it's so disruptive in the automotive industry, and with all the challenges we face in the supply chain with regard to other issues, electric vehicles is definitely another added challenge. In the supply chain, as far as EVs are concerned, so far we've seen some success in the two-wheeler industry. And of course, you cannot relate the two-wheeler industry to the passenger car industry at all. They're two completely different industries, completely different requirements in terms of end requirements from components. The supply chain has definitely been improving over the years. We've seen this challenge even with the normal ICE, the regular ICE, where we have a very fragmented tier 2 and a tier 3 supply chain. While the tier 1 supply chain is pretty, well oiled and is robust in terms of technology, in terms of joint venture partnerships, etc. The tier 2 and tier 3 supply chain is still a challenge because of the fragmentation that has happened over the years. The big challenge that we see is when we go to high volumes, how will the tier 2 and tier 3 supply chain, keep up? And therefore, the insistence from OEMs as well as tier 1 suppliers to invest more in technology, bring more joint ventures into the tier 2 and tier 3 space, have more investments in terms of manpower, skilling, equipment, machines, etc., so that we can really keep up. With regard to EV, we're still at the early stages where, I think the big challenge is going to be batteries. Other components we can still manage. I really feel that the big challenge going forward in terms of scale will be batteries, and that's something that we need to look at how we manage that whole aspect of the supply chain.
Right. Yeah. I think thanks for summing that up, Sanjay. Clearly, different challenges, and as we are going through a transition from IC to EV, I mean, a lot of profits come from the IC side, which OEMs can't take their eye off because that's what's going to fuel their EV growth. Clearly, just looking at it on the battery side, that seems to be the biggest cost right now. Possibly a big investment needed if we are to localize down to even a cell level. Obviously, that really is a big challenge, which very few markets, have that scale to kind of justify that sort of investment. But, just looking at, again, sticking to the supply side, Dr. Tuklensky, this whole issue of scale, clearly for you all, I would imagine scale is not so much of an issue. Earlier, we had heard that you could be quite flexible and ramp up your capacity accordingly. But the overall EV ecosystem, it seems to be it's around the battery, which really is the biggest challenge. You had earlier spoken of hydrogen being one way to kind of, mitigate that issue. But again, just your thoughts on the overall, issue of scale, and what are the clever ways of trying to overcome this, and the fact that the supply chain isn't really developed in a market like India.
Well, it's like always, it's a chicken and egg situation, right? I mean, on the one side, you need to establish the supply chain. On the other side, also you need to create demand. And I mean, where's the demand coming from? I think and I would like to start maybe answer your question from the demand side. I mean, what we have seen in countries like China, in European countries like Norway, electrification has kicked off and has been grown when government subsidies kicked in. So when there was an incentive also for the consumer to buy an electrical vehicle. Meanwhile, you get also in Germany, I think, for an electrical vehicle subsidies in the range of 8,000 euros from the government. You get also tax exemptions for cars. So there are significant incentives provided by the government. At the same time, also strict regulations. And I think first of all, you need a regulatory framework to create demand. And once demand is there, then also supply develops, right? I mean, what we see now, there's significant dominance from battery suppliers in Korea and China. I never expected also European OEMs to develop their own supply chain. Now, meanwhile, they are thinking about gigafactories for battery supply. I don't know if it's smart to close the market in the very beginning from external supplies. If I'm not mistaken, India is somehow trying to install import duties for electrical components. I don't know if this is the right way to develop demand. I would rather install some kind of incentives really to enjoy the industry, to invest in that. Yeah.
Right. Yeah, Mr. Kapoor, I think Dr. Tuklensky has raised an issue that's constantly being raised, which is really, fiscal incentives, be it by way of proper incentives or reduction in duties. Do you think this is a way forward? And also, we're talking about innovation, just given the kind of still subscale level we are at. Do you think some breakthrough is what is required, particularly around the big hurdle, which is the battery, be it in terms of some cost reductions or in terms of technologies? What do you think is the real way to kind of, let's say, to break through the current level we are? And of course, we are growing, but it's still a very, very small base.
Hormaz, I think, the government's definitely pushing in terms of FAME 2, PLI scheme for batteries, PLI scheme for automotive and components. So I think there's a lot of push from the government to, bring about this change or bring about localization, from a manufacturing perspective for electric vehicles.
That's right. The current PLI scheme is really geared towards localization and local manufacturing of the EV space.
Right, absolutely. So, I mean, it's more looking at future technologies. Let me put it that way. It may not be limited to EV, but it's future technologies.
Hydrogen
I think the government is cognizant of the fact that the industry is disruptive, and this is the need of the hour. So I feel, to Alex's point, his point is the fact is that we are looking at subsidies in a sense, by looking at schemes that the government is offering, which will benefit manufacturers. So I feel we're headed in the right direction. But again, this is not an easy problem to solve. Batteries is something that we've been grappling with for years and years. There's talk of solid state batteries, which could, solve the problem to some extent of range anxiety, etc. However, this is, an ongoing development that needs to continuously happen, and cost will go down over a period of time, and we've seen it go down already, and cost will continue to go down. But this is an issue that needs to be addressed.
Right. And, Dr. Tuplensky, just taking off from what Sanjay said, that, looking for some breakthroughs. He talked about solid state batteries. That's also being talked about. A lot of challenges there. Alternatives to lithium ion for obvious reasons, costs coming down. Do you think we need one major breakthrough to really kind of for the space to, let's say, exponentially grow? Or do you think we are on the right path? Or do you think some sort of innovation is needed further?
I mean, what we are experiencing now is so much innovation around the car industry, which we haven't had for the last 100 years, right? I mean, everything is changing within a just short period of time, and I mean, not only the powertrain itself, but also the way how you sell mobility, as also the business model behind mobility. Owning a car is maybe something which has been in the past business model. Now sharing cars is something what is also becoming more and more of interest in, at least in Europe and in the Americas. And maybe this is also something which I can well imagine for big cities in India. Yeah, not owning a car, but just sharing a car. So everything is somehow changing with a pace we've never experienced before. And I doubt that there will be only one powertrain in the future. I believe we will have different kinds of powertrains. We can also think about synthetic fuels, which is also, if we come from the climate point of view, maybe there are also some areas where synthetic fuels make sense. I mean, how do you want to electrify continents like Africa? I mean, this will take decades to do so. So I think in the future we will deal with different kinds of powertrains, and there are many good reasons for this and this powertrain. So flexibility, I think, is also key, to be open.
Right. No, that's an interesting point, actually, and as you said, with synthetic fuels, carbon neutral fuels, that's really the last hope for the IC engines, and especially in markets which are hard to electrify. That could be, the breakthrough the IC engine probably might get to survive. Mr. Kapoor, turning to you, just looking at various trends, obviously you're focused a lot on EV motors. You've heard, there is still a lot of scope for the good old IC engine. I mean, a lot of manufacturers have announced that they're going to phase them out within a decade or so. But, looking at your space fundamentally, which is around motors, around components for the EV space, what are the new innovations and technologies you find exciting and you all are working on, which, might give that kind of push us closer to that tipping point?
Yeah, so Hormaz, the motor industry is extremely disruptive. Right. There's a lot of development going on in terms of motors. We are looking at development of magnetless motors, so we can eliminate the whole dependence on rare earth materials. There's a lot of different ways of generating power and different people are working on different solutions. And I think, this is a very, very interesting time, because there's not just innovation in AC, but in DC motors as well, with regard to axial flux, radial flux, in terms of how the power is generated. And we see a lot of opportunities in this space because, for us, India is a large two-wheeler market. And that's a market that we can address, which will very quickly move to electrification. And having said this, the problem is not very big for us because, it's all sub 100 kV motors and it's easy to manage. However, the challenge is in the four-wheeler space, because the motor is completely different from the two-wheeler. So what we've been able to achieve in the two-wheeler space globally, I don't think we can just replicate that in the four-wheeler space. So there's a lot of work going on in terms of innovation in that space as well. And it's an exciting time.
Right. And sticking with you, Mr. Kapoor, you talked about the two-wheeler space. Obviously, with its sheer scale, probably the innovation will be driven there. But just looking at the Indian market, which is so cost sensitive, and clearly, the EVs are still disadvantaged in that area. We are a super, super cost sensitive market. Do you think innovation will come in areas of cost reduction? I mean, is that the focus? And I'd like to, after that, turn to Dr. Tuklensky. But just this whole issue of, bringing down costs as much as possible. Yes, government incentives are there. Will they be there forever? Possibly not. The technology has to stand on its own feet from an economic standpoint. So and looking at India, just how super, price sensitive this market is. Do you think that's a challenge and a lot of breakthroughs will be coming in that rather than absolute cutting edge technology?
Yeah, so I think cost, efficiency, and safety. These are the three things that are going to determine who will win the race, in the motor business or in the component space in India. With regard to innovation, Hormaz, there's a lot of innovation has happened in the two-wheeler space. You've seen what's happened in China. India has also had a lot of different sort of developments, etc. I think, it's time that, this will sort of be determined purely, as you rightly say, by cost, efficiency, and safety. And that's my view on.
Right. Dr. Tuklensky, India, as you probably figured out, a super cost-sensitive market, and it's been make or break. Let's say if you see the history of the auto industry, and the successful companies over here, it's the ones who are successful is those who have managed their cost base very well, and those who haven't have even had to exit. We've seen recently the announcement of Ford stopping manufacturing operations here because this is too hard a market to crack and even make profits in. So, from your point of view, obviously you are looking at technology on one side, but markets like India, is there pressures also on cost reduction and, meeting certain very brutal cost targets here?
Absolutely. I mean, we are well aware of that. But we perceive ourselves as a supplier of high performance materials, as a premium supplier, and by saying that, we are trying to outperform with high quality products. Somehow, if we look at the final part, at the component cost, and this is what counts at the end of the day, that we combine good material with smart engineering know-how to come to, at the end, achieve components which have lower cost. Yeah. So then you may need, if we apply, for instance, smart lightweight solutions, if you need less material of our premium material, then at the end you have lower component costs. If you can manage to reduce cycle time, they can also lower component costs. So this is what we look at. At the end, the component, not the material price itself. And this is also where our engineering services and technical services in Asia and all over the world can help. Yeah. Or,
right.
I mean, if we look at the electrification of powertrain, we come across with materials which are really, cutting edge, yeah, and which you need, I don't know, to manage a certain objective, like removing heat from a charging socket, I don't know, providing flame retardancy, V0 flame retardancy for housing or for charging um, um, gun, whatever. Yeah. So it's basically both. And at the end, we always look at the performance and component costs.
Right. And, just, looking at engineering plastics, what y'all are focusing on, do you think this has, but there's a lot of scope for this in the overall, EV efficiency improvement in terms of, cost structures and things like that? And as you said, your high performance, obviously adding value rather than just reducing cost.
Yes, so we strongly believe that per vehicle, with this transition from combustion engines to electrical vehicles, you need more engineering plastics in the car itself, mainly around the battery housing, maybe also. Now these days you have a completely new car architecture. You can also imagine to have structural parts made from composites or fiber reinforced engineering plastics around the battery or combining metal and plastics in the car architecture, and also in everything like autonomous driving sensors. I mean, we've shown that, and Jürgen will touch it also later in his presentation. We believe the demand for engineering plastics will grow, and we are open. We invite everybody to work, to cooperate with us on new solutions.
Right. And, Mr. Kapoor, turning to you, I just want to touch upon, let's say, which I think Dr. Tuklensky had talked about, plastics, obviously, turning to lightweight materials, because clearly I think one of the enemies of EVs is weight. Batteries are inherently heavy. Heavy batteries mean lower range, more cost, performance issues, that sort of thing. So obviously, lightweighting is super important in EVs. So, just to get your sense, what's being done in the area? I mean, is this a major focus in terms of kind of really reducing the overall weight of a BEV, which is just substantially more than an ICE equivalent?
So, we've been working on lightweighting right from the beginning, right from ICE. It helps with fuel efficiency in ICE and definitely in BEVs, in battery electric vehicles. The lighter it is, the more the range will be, and it'll solve a lot of problems. So lightweighting is not new to us in the component industry. It brings down cost as well, and it brings down our overall cost. And we've been working on it from the ICE days. As mentioned, new materials, whether it be carbon fiber, these are materials that people are exploring with. There's a lot of research and engineering going on in terms of raw material and how we can, to give you an example that I gave earlier, we as an organization are working on building a magnetless motor, which of course will change the cost and the weight of the motor. So this is something that companies are actively working with, and we cannot not work towards lightweighting.
Yeah, but just sticking with you, but do you feel that the challenge with lightweighting is that obviously with lightweighting you save on various other costs like running costs, especially whether it's with an IC engine, fuel costs, range with a BEV, and that again is a saving cost. But at the same time, some of these materials are quite expensive. You spoke of carbon fiber, very high-tech material. So is that a bit of a challenge, and to find that balance of where to use, these specialized lightweight materials, which typically could be costly, and, throw the whole cost equation out of whack because it doesn't compensate then for the savings which they offer. So just wanted to get your sense on, is this a bit of tightrope you have to walk?
So Hormaz, definitely raw material is one way of doing it. There are other ways of looking at lightweighting, but raw material is definitely an easier or a more obvious way of doing it. And I think, as scale increases, as the volume increase, costs will come down. and we've seen that in the case of everything, in terms of batteries as well. As the volumes increase, we're hopeful that costs come down. But definitely today it is a challenge. When you look at carbon fiber, there is a definite cost disadvantage.
Right. Dr. Duklensky, I'm sure you could throw a lot of light there, because being so, specialized and invested in the whole materials, of the ecosystem, this whole kind of, let's say, challenge or issue between cost and lightweight and the raw materials, which are inherently lightweight but expensive. So, is this a balance that, as Sanjay says, might not be such an issue as we get more scale? Is it a challenge now, and going forward, are there any innovations we can see in terms of alternate materials which are not so expensive but yet pretty lightweight going forward?
I mean, what we are facing these days is a challenge in the global supply chain of everything. I mean, if we look at our suppliers of major raw materials, but also small additives, there is one force majeure announcement announcing following the others. Yeah, so this is, I mean, these days, raw material procurement is really a big challenge. And wherever you look at, this is not only our industry. I mean, I believe you also, everybody in this call is somehow suffering from global supply chain interruptions. And we also believe this will be maintained for the next year as well. In the long run, what we see as a raw material supplier is that sustainability topic. I mentioned it earlier. Sustainability is the license to operate, driven by governmental regulations. But also we see more and more customers, mainly in B2C, but also coming more and more in B2B business, asking for sustainable solutions. And latest when CO2 emissions will be added with a, let's call it a price penalty or price tax, a CO2 tax. Then sustainable solutions, offering sustainable solutions is somehow a competitive advantage. And this will come sooner or later. It will most likely start in Europe, but we believe sooner or later this will be part of every economy in the world, that we will have to provide sustainable solutions. And this is also where we see a really strong need for innovative solutions also. And this is not only an issue for the material supplier, this is an issue for the entire industry. This means producing something, using it, then returning this again to the material supplier. And apart from the powertrain transformation, this is the other big innovation topic we are working on.
Right. Mr. Kapoor, Dr. Duklensky raised the issue that raw materials right now, just getting supply is a challenge, cost is a challenge. And, you represent the component industry. Of course, I think no panel can not discuss the certain shortages we are facing, especially with semiconductors and things like that. But, even the broader issue of raw materials cost and the fact that costs are just growing through the roof. From representing the supplier industry, I mean, this obviously is a big challenge. And do you think this is going to drive innovation to look at, let's say, alternate opportunities and technologies? Or do you think this is just a kind of a short-term issue that once there's more capacity and everyone kind of figures what the scale of the problem is and kind of deploys capacity to that extent, it might settle down?
Parmaz, that's a very big question in terms of how I should answer that. So there's multiple ways of looking at this. I mean, or multiple problems or issues or challenges here. One is the semiconductor challenge, which you talk about and the entire industry is talking about. The fact is that we buy only 7% of the output of the semiconductor output as an industry, as an automotive industry, not just components, which forces us to buy from distributors as opposed to manufacturers, and therein lies the challenge with regard to the leverage that we have. The other problem is that a lot of capacity got diverted during the lockdown to other industries. And the fact is that chips are increasingly being used in every industry. For example, in the automotive industry, the chip shortages also because of the fact that we've, increased the number of chips in a car because of the whole connectivity, the whole smart car, etc. Other industries have also increased the number of chips they're using, and I feel that the chip shortage will percolate into other industries as well very quickly. This is something that we're trying to resolve by, trying to understand capacities. There's not an easy solution. I don't think that we will find a solution very quickly either. The ability to put up capacity is very expensive. It's almost a $3 to $5 billion investment with an 18 to 36 month time lag before you have anything out. So I think this is something that is definitely a challenge for the automotive industry. OEMs are in conversation with governments to see how we can take this forward. I think there's a great opportunity also maybe to set up chip manufacturing, locally. Maybe this is something that India can do, and we're examining different options. With regard to innovations in the supply chain because of cost, that's a constant. Fortunately, in the automotive industry, we've been able to develop a lot of technologies in India as well as outside of India. But when I talk about India specifically, we've invested heavily in R&D, across the board, and been able to develop a lot of technologies. And we'll continue to see innovation in that space. Raw material is something that we can see a lot of innovation in. But again, your point of cost versus the end benefit. So we're definitely this is not a short-term problem. I mean, the problem may be short-term, but the solution is we need to think for long-term. Coupled with the fact that we have raw material prices rising, we also have container shortages. So again, there's a lot of supply challenges in the automotive industry. However, we're a resilient industry, and we will come out of this, and we will find the right solutions and the right innovative solutions in the whole supply chain challenge.
No, thanks for that. Very insightful comments, Sanjay, and a bit of a worrying outlook you've painted over there. Just leads me to one question. Strategically, should OEMs, or I would say rather markets, regions, or even countries be looking at being a little bit more vertically integrated in that sense, just to kind of secure future supplies of very key components, be it semiconductors or batteries at a cell level? Do you think that's, we would move back to the old days going forward in this very disruptive age of really kind of controlling, really key technologies by looking at more vertical integration?
Yeah, I think it's a cycle. We go into that cycle of completely outsourcing and then completely bringing things back in, depending on where we are in the cycle in terms of the challenges that we face. And I feel that this is a great opportunity for India really to set up semiconductor manufacturing, because again, this is a shortage not just in the automotive industry. We're seeing it in the automotive today. However, like I said, we're going to see it in other industries too. This is a real challenge, just because we've run out of capacity, because the number of chips being used, and we cannot get away from using chips. We can't, now suddenly bring out cars with fewer chips because it's just not viable.
Right. And obviously, I think one good thing is that the PLI has come at a very right time, in kind of making us more, how do I say, manufacturers.
Future ready.
Yeah,
Future
that's
ready.
right. Future ready. Absolutely. You said the words. But, but with that, does this mean, with the PLI schemes that we now have an opportunity to become a global export hub for EV components? And, it's a question to you because I'm sure you do export all over as well. But do we have the scale? And is this really the key that, when you become, let's say, a source of export globally, you can control your cards and destiny a bit better?
Yeah, I mean, we definitely, that's the aim of the PLI to, it was, I think when we started talking about the PLI a couple of years ago, it was about creating export champions and creating a manufacturing hub for the world. We have the capability to do it. Private sector's job or role is to really invest in technology. And we are investing in technologies for the future, so that we can create a manufacturing hub in India. I think we're sitting in a good position to do that. And yeah, we are working towards that. And that is the way forward. If we really want to achieve innovation, scale, and any kind of strength, we need to look at creating a manufacturing hub in India for the world.
Right. Dr. Toplensky, turning to you, you've heard, Mr. Kapoor. I mean, at one level, he paints not such a rosy picture, just given the current situation on semiconductors, which is really reflective of where the industry sits in the overall semiconductor ecosystem. But at the same time, there are opportunity. And again, it all boils down to scale. Just from your side, development of battery module support systems, kind of, let's say, more vertical integration in India with OEMs. Do you think that's the way forward? And obviously, at some point, we will, and I believe that will happen, that we will have to be looking at manufacturing, cells in India as well as kind of the ultimate level of, localization.
Yeah, I totally agree. There is so much opportunity out there in this market that it absolutely makes sense just to jump on this big train of change. I just want to give you an example. We have just a few days back we have looked at our customers. We are mainly supplying to tier customers, to tier suppliers, not directly to OEMs, and we have looked at how they are somehow adapting themselves to the change in the industry, and in some of them they completely, tier suppliers which have been so far in the under the hood business, they're completely stepping into new fields in the electrical vehicles. So because they see opportunities, they take a risk, but they also see big opportunities. And I can well imagine also completely new areas without any experience in that field, but with a clear vision and a strategy. And I can well imagine that there are many opportunities for Indian component producers, for Indian tier one suppliers, to find niches and opportunities to make new business. Absolutely.
Right. And from your point of view, you said this earlier. Do you think there are any recommendations or change in regulations, not just here, but across the globe, from obviously the local authorities, governments, in this area? I mean, do you think anything more needs to be done, to kind of, let's say, fuel growth, fuel innovation?
Yeah, as I mentioned earlier, I think you have to create the demand in India. I mean, who is willing to spend money for an electrical vehicle, which is maybe even more expensive than a combustion engine, and with limited spaces to charge the car? I mean, you need somehow yeah, you need these incentives, but also you need to, well, push the government, the authorities to build up, or also to support the electrical infrastructure. And I think without support from the government, it's very difficult to create this local demand. This is
Right.
this is our experience, how we see it in Europe, and I think this was also the same case in China, and I guess also in Korea.
Right. Sanjay, turning to you, obviously the big news today is the PLI scheme, which is a big incentive for future technologies. But as Dr. Tuklinsky said, that we have to kind of create the demand, and sometimes one gets the feeling that no one puts the consumer at the heart of the decision-making process sufficiently. I mean, it's not, does more need to be done? I mean, vehicles are still quite expensive. That's one issue. Charging infrastructure is another issue. Range is another issue. Do you think, that some more can be done to kind of create that demand? Because without the demand, you don't get the scale. And then obviously this whole chicken and egg situation, comes in.
Yeah, I mean, demand creation is definitely a challenge. We've been in conversation multiple times with government about GST, about reduction, etc. I think the government has pushed through the PLI scheme to really create again a manufacturing or a supply side. And this is from a global perspective, not just limited to India. And so I think demand creation, will happen, and it happens in different ways in different countries. In some countries, of course, it's driven by subsidies, and that's also not a sustainable way of creating demand. So I feel that if we continue to work towards and I also feel that affordability is a key driver for demand. So as people can afford more, and as affordability goes up, demand will automatically go up. We've seen a great revival from the lockdown. After the first lockdown we went through, the first phase of the pandemic, we saw a lot of demand in terms of passenger car as well as in the tractor industry. And we hope that demand stays strong.
Right. And, I think, as winding up, because I think we'd like to take some questions as well, just to get from each one of you, your overall perspective on, a macro level view of electric mobility going forward. I think, Dr. Tuklinsky, you gave a kind of a pragmatic view that, there are multiple technologies, there's hydrogen, there's synthetic fuels. Do you feel there's a fear of, being too technology specific rather than technology agnostic in some way? I mean, at the end of the day, what we want to all do is be carbon zero or carbon neutral. But there are multiple ways to do this. But the way things are going, it seems to be that the BEV is the only way. And that's something which even governments are, following that view. Do you think we need to take a more kind of a holistic view of this? Because who knows, I think every technology should be given a chance with innovation if they have a breakthrough. But to be honest, at one level, I think diesel, it was, didn't get its due because from a CO2 perspective, it kind of works better in the transition than even petrol does. But of course, it's had its own issues and has been effectively killed. Maybe not given a fair chance, as a lot of people say. Do you think we run this risk as well, the way we are going in certain markets?
Well, I believe we should be open to any kind of technology, and I think in the long run, technology and innovation will always win. But on the other hand, of course, you need to see what is doable. If I look at these big OEMs like VW, I mean, they have only limited resources to somehow also to finance this technology change, right? I mean, imagine they would go for electrification, they would go for fuel cell. They just simply don't have the resources, and this transition is so costly. I think at a certain point in time, you just have to take a strategic decision. I follow that way. And of course, this was in many regions of the world. This is also supported by the government. I believe in the long run, we will have for different mobility concepts also different technologies in space in place. So that's why we also look at where we can provide benefits to these different technologies, but we will definitely also not look into everything. Yeah.
Right.
So at the end, I think this is, I mean, everybody does. You need to somehow find your focus, focus your resources, and focus on that what you can do best.
Right. That's an interesting point you made, Mr. Kapoor. Dr. Tuklensky said, which is true, that even if a company like or an automaker like Volkswagen has limited resources, I think smaller companies definitely in terms of resource, in terms of investment, in a very, very difficult spot. Can't kind of target different technologies. They have to pick one. Being a supplier, I mean, what is the trend? Are you seeing that, let's say there is now a definite trend towards, obviously, there's hydrogen, there's, BEVs, but a lot of your components kind of work for both, let's say sources, fuel sources. But just the overall, let's say a macro level view, and especially with India, what is your sense? Is this pace going to accelerate very fast, or do you think there will be at some point a kind of an inflection point that, we've just got to kind of maybe dial down a bit to be realistic about the investments, the ecosystem, and just some practical considerations as well?
I feel that this will happen very rapidly. I think we will go electric very rapidly. And I also think that one thing that we need to look at is renewable energy, and that's also being looked at, being talked about. I'm reading a lot of sort of stuff around people investing in renewable energy in India, to help with the growth of electrification. And I feel that, and you talk about, people, are we thinking about the consumer, the end consumer? I think the end consumer is also driving this demand. It's not only regulation, and you spoke about this earlier as well, both regulation as well as the consumer driving this demand. And that's where it's coming from. And we've seen that globally. Most end consumers today don't want to buy anything unless it's electric. And there's a big drive towards that. And I don't see how we will not see this in India. I think India will see this as well. We will go electric. Of course, there are different stages in terms of, the segment. And I think the two-wheeler and three-wheeler are the low-hanging fruits, and they will sort of go electric much sooner than anything else. And then passenger movement, last mile connectivity, goods carriers, etc. So I think it's an evolution which will happen very quickly, very rapidly. 5 years ago, I didn't think it would happen as rapidly. I knew it would happen, or I had a feeling it would happen, but not this rapidly. And every year, we hear about sustainability, and we hear about the Paris Accord, etc. Everything gets pushed forward 5 years. So again, what people wanted to do in 2030, they want to now do by 2023. So I don't see us, going slow on this. It's here to stay, and I think we need to, embrace the change, and we need to prepare for it, because we can't avoid it. It's great to want to be technology agnostic, to solve the end goal of emissions, etc. However, from what I see currently, and this may change, overnight, but most OEMs are working towards electrification.
Thanks, Sanjay. With that, I mean, I think, you've kind of, in a way, wrapped up what is happening right now. Of course, electrification is inevitable. It's how fast, how quickly, But I think what's clear is going to be much faster than most of us think. Looking forward at the way the world is moving. Obviously, some sectors will be faster than others, like the two-wheeler and the three-wheeler industry, which needs last mile with last mile connectivity. Four-wheelers, of course, at a slower pace, that is for sure. But I think, it's been a very, very enriching and enlightening discussion with both of you. Thanks for sharing your views, and also, in a way, giving a reality check as to, what the challenges are. But of course, there are a lot of opportunities and a lot of, let's say, innovation that will drive that. Of course, the breakthroughs will come, and that again will further push electrification to a different level. And with that, I just like to thank all of you all. But I think before we let you go, I think there are some questions. I'm wondering whether I would take this, or can I just give it to my colleague Mayank? Mayank, can you just help me out with this? If you could just take some questions, and then you can. Yeah.
Thank you so much for that panel discussion, Mr. Kapoor, Mr. Dr. Tuklenski, and Hormus, for taking us through a series of deliberations on the very key critical subject here, the shifting dynamics in the mobility segment. You've talked about these different aspects regarding e-mobility, the challenges. I want to point out on one particular aspect, which is like infrastructure. So we are seeing a lot of developments happening on the infrastructure side. A lot of companies, for instance, Tata Power and all, they're coming up and they're setting up these public chargers. But what about the actual ground realities? We are seeing people who are living in apartments, they're still facing issues. They're not being able to, they're not getting allowed these charging, the chargers being fixed in the societies. And also, Mr. Kapoor, any thoughts there? I mean, how do you see this space evolving with respect to the infrastructure challenges that we are seeing with respect to e-mobility?
So, Mayank, this is a very sort of difficult question for me to answer, because the fact is that, we are looking at electrification. We are looking at rapid change to electrification. And I think infrastructure will get built around it. We've seen that happen elsewhere as well. You build the system and the infrastructure gets built because it has to get built. So, whilst we face challenges today in terms of people getting electricity in their homes, I think the challenges were much worse 5, 7, 10 years ago. And it's ever evolving, it's improving. I think this will force us also to build the right infrastructure so to keep up with the times and keep up with the technology and the shift in technology. And this is a shift in technology across the board, and therefore the infrastructure, I feel, will get built. The ecosystem will get built. It's not just the infrastructure. We need to look at the entire ecosystem.
Right. Dr. Tuklenski, your thoughts on this, please? I mean, how can India kind of learn from what has happened in developed economies in terms of the charging infrastructure?
Well, I can totally agree to what Sanjay said. At the end, you need to invest in the infrastructure. You need to build this ecosystem, but also, of course, you have to develop further the technology, like fast chargers. This is something like we have today. Petrol stations. I can imagine that people go there with a fast charging system and charge their battery electric vehicle maybe in 20 minutes or 50 minutes. If you provide the right technology. And this is also, again, where innovation kicks in, in technology development. So this thing with infrastructure in apartment buildings, I mean, this is nothing you can really solve. So that's why we need to develop somehow other solutions. And I'm quite sure we will come to solutions which fits into, well, the German infrastructure and also the Indian infrastructure. Yeah.
Sure. Mr. Kapoor, there's one question for you. You talked about, Sona Comstar working on magnetless motors. So if you can just shed some more light on that, what's the timeline and when do you sort of plan to bring that out in the market?
So Mayank, at this point, I can just only disclose that we are working with an Israeli company. We're in an R&D phase at this point in time.
Okay, sure. There's another question from Mr. Sawant. He wants to understand that considering all the hype that's being created regarding electric mobility with respect to safeguarding the environment, to what extent the issue of disposal of the batteries has been evaluated and assessed at this point?
You're asking me that question?
You or Mr. Tuklinski, whoever wants to take that.
Well, we see
That's an interesting question. Let's hear it from both, actually.
Yeah.
We as a material supplier, of course, we are not only providing engineering plastics, we're also working on producing electrolytes for batteries. And of course, we're also interested in looking at the battery recycling technology, and companies like BASF, they're also working on that. And I can well imagine a system where you just return a whole battery system, and we as a plastic producer then return the materials from all the plastic materials, and others just return the metals from the battery. We have to close this recycling loops. Yeah, this is definitely also one area where we need R&D and where we need innovation. Yeah, and also of course business models, ecosystems, actually, to bring batteries into a cycle.
Sure. Mr. Kapoor, your thoughts on this? I mean, creating a circular economy with respect to the batteries and extracting the raw materials.
I completely agree, with what Axel said in terms of this is an ecosystem issue. When we talked about infrastructure and I touched upon ecosystem, I think this is an ecosystem issue, and this is a very critical part of the entire, sort of EV life. Disposing, and disposing it correctly. And recycling, etc., is extremely critical to achieving success in the process. So, it's not just going electric, but I think there comes a lot of responsibility. And Axel talked about sustainability earlier on in the discussion. Again, this comes back to, are we able to create a sustainable solution for a sustainable environment?
Sure. Sticking to sustainability, Mr. Kapoor, with regard to renewable energy, India has a very strong mandate on solar power. So going forward, how do you see this emerging? I mean, are we only going to be looking at like large solar, farms with solar panels installed, or do you think that independent solar panels at rooftops, at offices, are those also going to be playing a very key role?
So I think we're very well positioned for solar energy. I mean, I don't see a country that, has as much sunlight as we do. So I think, it'll be a natural step for us to look at solar energy. And, there's a lot of announcements being made in terms of investments in renewable energy, which is very positive, which is very encouraging. And I feel that we need to gear up towards, that whole movement towards renewable energy. And, companies are doing it at their own level already. Several companies are installing, solar panels to move towards renewable energy. And I think that's the way forward, even in terms of large scale. And it's the right way to go.
Right. Dr. Tuklinski, a gentleman wants to understand, is there a possibility for solar cars as well?
For against solar what?
Solar cars, vehicles that run directly on solar power.
I doubt that you can charge the car with solar panels on your roof. But what you can do is you can put solar panels on the roof of your house, and then charge the car from there. I don't know if you get really enough area on your car to be sustainable, to get enough energy from that. But I have to admit I'm not the expert in that area.
Right. Mr. Kapoor, we've talked about this whole de-risking the supply chain bit. You've discussed this in the panel. So, from a raw material perspective, even if we talk about localizing a lot of these electric components in India, what happens to the raw material? We still have to be dependent upon, countries like China, which have a strong hold on some of these rare earth materials.
Yeah, we're going to have to innovate in that space, Mayank. I think there's a great opportunity for localization of electronics. As a country, we will import almost $250 billion worth of electronics by 2025. So therein lies a great opportunity to localize. And I said this, in another discussion earlier yesterday, where I said, we need to come together as industries, electronics, automotive, etc., to look at how we can together build scale to localize electronics. And once we do that, we'll be able to resolve the problem of raw material dependence. And like I said, we're doing it. We're working on doing it by going magnetless motors, where we will have no dependence on rare earth materials, which is imported today, from China. So, we will, continue to innovate to find solutions. I think that's just the nature of the industry we're in.
Sure. We've talked about innovation. There's another question that comes up from Mr. Sonal Sharma. He wants to understand, what about alliances within the component space? I mean, is collaboration among tier one supplier going to help India leapfrog in the EV space?
Absolutely. I mean, collaboration is always a positive. There is hardly any negatives in a collaboration. And we in the Indian component space, we worked with collaborations. We started our businesses. Several of us started our businesses with collaborations with Japanese companies for technology. And I think if we collaborate with each other going forward, that's the best way for us to win. So we will see collaborations, hopefully, even as we go into sort of more investments in electric vehicles and that whole space.
Sure. Dr. Tuklinski, I'll just come to you with this question. Electric is still not the last word when it comes to sustainable mobility. You've also mentioned in your presentation that we need to focus on hydrogen and other areas as well. So is it how crucial is it right now to not put all eggs in one basket when we talk about sustainable mobility?
Well, of course, it always depends on where you're coming from. I mean, as a company with limited resources and R&D, with limited financial capacity, I would always recommend to focus on what you are best in, right? So it's of course everybody who is, I mentioned earlier, one tier supplier we are also working with. They completely stepped into a new area. They are now working on in a new field in the powertrain, and trying to succeed because they see the existing business somehow fading away. But I mean, the question is, how many of those kind of strategic projects can you handle and can you finance as a corporation, right? So I think you should always look at upcoming trends and then evaluate, is this within my focus or not? Do I keep it on my radar screen? Do I put all my resources on that or not? So I think there's not a wrong or right answer on that. I think it depends. It really depends. So we put significant resources, in our case, on opportunities in the electrical powertrain. If you ask me, we put 60% of our resources in the electrical powertrain, maybe 10% look at hydrogen opportunities, and the rest is looking into existing business of the combustion engines. And so this is how we balance our R&D activities, right?
Sure. Hormuz, I'd like to give the last word to you on this. Dr. Tuklinski has touched upon hydrogen, and we've had a very good discussion on EVs. You've driven the Toyota Mirai, which is a fuel cell vehicle, and you've seen the Audi e-tron GT getting launched in India just recently. So what is your opinion about the way forward? I mean, what sort of technologies do you think becoming mainstream and space? Yeah.
Personally, I'm technology agnostic. I think clearly what's clear that is we've got to get the carbon out of our system, so to speak. And that's very important. Whether it's with renewable energy, hydrogen, synthetic fuels, that's clear. But I'll just share some practical, let's say issues which I have faced not really long back, because we put a lot of EV miles under us over here. Just last week we were driving to renewable energy plants. To be honest, in a Mercedes EQC, we were visiting every renewable energy plant in a small span and actually charging from there. Just to prove the point that it's really clean when even your EV is charged by a renewable plant. But getting there, charging, we had issues. We turned up at a charger. We had 2 cars before us. We had to wait for 1 hour. And these are just 25 kilowatt chargers. This battery is an 80 kilowatt battery. We had a problem there. Then then we got to our night halt, and we said, okay, great, we can charge the battery there overnight, again a 25 kilowatt charger. But guess what? The power kept going off. And with these chargers, it doesn't just come back on like your mobile phone. You have to go down and reprogram it and recharge it. So these are practical issues. But I think it's something that you just accept and you learn to live with. These are teething problems, and frankly, it is possible. It's just like the early days, when you drove around where there was no infrastructure for fuel. You sometimes even carried it, or you just planned better. But on a practical side, it is still challenging, and that's why I think my view is we need to just be sometimes a little circumspect before we just charge headlong into just one kind of technology direction. Well, that's my point of view. My tube is just from living with the EVs day in and day out, which we do for a living.
Right. So on that note, I think you've summarized it very well. We shouldn't be just looking at one technology here, which is EV. I mean, surely going forward, we might see a lot of other things evolve, and the teething issues, the niggles that you're talking about, that we're facing right now, maybe as the technology improves even further. So going forward, we might just, see everything getting smoothened out. So with that, thank you very much for that wonderful panel discussion, Mr. Kapoor, Dr. Tuklinski, Hormuz. Thank you very much for your time and giving us all your thoughts on this very interesting topic. Thank you so much.
Thank you
very much for having us.
Thank you.
Thanks, Hormuz.
Bye. Thank you. Thanks, Sanjay. Bye. Thank you. Bye.
So with that, we move to the last technical presentation of the day on the day 3 of the Autocar Professional EV Forum. The presentation is on the topic Engineering Plastic Solutions for New Mobility. I would again like to invite Mr. Jorgen Selig, Head of Application Development, Lanxess, Hong Kong. Mr. Jorgen has studied material science and is
Sorry to interrupt. Can we play one video clip before Jorgen takes over for his presentation?
Yes, absolutely.
Maybe, maybe a Mahle one?
Yes, absolutely, please.
Yeah, thank you.
Good afternoon, Lanxess team. I am Sandeep Deshpande, responsible for business development and purchase in Mahle Anand Thermal System. We have 5 plants in India, and we are supplying HVAC, that is heating, ventilation, air conditioning, and engine cooling module products to various customers in passenger car segment as well as commercial vehicles. We have a long association with Lanxess, and this is continued for last 10 years. We get a good support from Lanxess in getting a technical solutions at the design stage, as well as we get a good support for establishing products at supplier end, particularly for developing the parts as well as proving it in the technical testing validation cycles. We are looking forward for continuing this support in future business. We have various products wherein we use Lanxess material, particularly for radiator, charge air cooler, and fan motor shroud. In electrical vehicle segment, we are bringing various products to India. We have started association with OEMs in India. We are bringing products related to battery cooling. We also are bringing products related to cabin cooling and motor cooling. Electrical vehicles will be requiring the heat pump, HVAC, because heating, ventilation, air conditioning is required for cabin cooling. as well as we require heat exchangers for cooling down battery as well as motors. We require a good solution from Lancex, technical solution which will give optimized design, lightweighting, as well as cost-effective solutions which will bring more business to Mahaly Anand Thermal System. We look forward for good association with Lancex and looking forward for a fast growth in India. Thank you very much and have a nice conference ahead. Thank you.
Wonderful. So with that, we would now move to the last technical presentation of the day. And again, I would like to give a brief introduction. The topic is going to be engineering plastic solutions for new mobility. And it's going to be delivered by Mr. Jorgen Selig, who is the head of application development at Lanxess Hong Kong. Mr. Jorgen has studied material sciences and is a major in polymer science from Erlangen, Germany. After studying polymer sciences and several years in project management in the automotive supplier industry, Jorgen joined Lanxess High Performance Materials in 2006. Since 2012, he is responsible for application development at Lanxess Hong Kong for the APAC region, with an increasing focus on electric mobility. With that, over to you, Jorgen, but I would request our audience to type in their questions in the Q&A box, and we will take those with Jorgen at the end of his presentation. Jorgen, over to you.
Okay, thank you, Mayank, and welcome everybody to this presentation. Now we'll go a bit deeper and we look in depth into engineering plastics for electric mobility for new applications in the electric powertrain. Now I'll try to share my screen. I hope that works properly. If not, we fall back to the presentation you have.
Good to go, Jorgen.
Visible?
Yes.
Okay, perfect. Okay, then let's start. Yeah, so I'll talk about engineering plastic solutions for the new electric powertrain. So we go deeper. And so I chose to pick examples of projects that already happened. So they can serve as a good example of what is possible here and now. Yeah, a quick look at the agenda. So first we look at the new application areas quickly, and then we come to project highlights, namely to a battery module assembly, a so-called mainframe, a charging inlet, higher voltage connector, and last but not least, the battery housing itself. Yeah, you've seen this overview before, and this reflects pretty much our understanding. When we look at electric cars, new electric powertrains, then we look, of course, at the battery system with various new components. Also, the 48-volt battery for mild hybrid cars. We look at control units, the motor, of course, the charging system, connectors, high voltage connectors, to some extent also to auxiliary equipment. And although most of what I am about to talk about is related to four-wheelers, to cars, some of that can also be carried over to two-wheelers. Now let's get right into it. So these are the 5 project highlight examples that I'm about to show you. So we start with the battery module housing. So yeah, this is a kind of explosion here. We see here a battery module schematically using prismatic cells. And we see several components that are of interest: the side plates, end plates, so-called bus bar holder, covers. And so what our customer asked us here is they need material which has, of course, a good flame retardancy. This is really the prime newly added property. The V0, but for different range, I'll come to that later. They also added a maximum CTI of 600 volts. Another demanding requirement is maximum contact corrosion, and of course also some good mechanical balance of stiffness, strength, creep resistance. And Of course, you also need good processing capability. The best properties are useless if the materials don't work on the machine. So how can we do this? And here we see it a little bit more realistic. So this is a encapsulation, using several components, as you can see here. And so how can we do this? How can we get this done? Now, first of all, I want to show, have a quick look at some of these essential tests. Not all of you may be familiar with the UL94 V0 test and the CTI test, so I can explain very quickly. So the UL94 flame test is a vertical test, a very much established test standard. So it measures actually of how fast material extinguishes after removal of the fire source. V0 is the best rating. And the CTI is equally established, I would say, or similarly established. And that actually evaluates the formation of tracking path under voltage and electrolytes. So it means in reality, it gives you an idea of how fast a plastic component would fail to be electrically insulating. Well, that's why a rather important test. So with that, we move on. Now, when we look at our halogen-free flame retardant material portfolio already, and some of them are shown here, then we have already excellent materials from the E&D industry in our hands. PS6 and PS66 based, we call this the FN series, halogen-free materials, and you see they all have fantastic V0 rating down to 0.4 millimeters. And now what is especially good about them, besides the flame rating, is they are all halogen and red phosphorus free. So that's important because red phosphorus containing materials can cause problems under very humid conditions. They can cause contact corrosion. And that you can imagine when we're in the battery is something that must be avoided at all costs. And then we picked out here two materials, and one is a really pretty special, the BKV40 5FN04, 45% reinforced, has top listings, UL top listings, and features also very high mechanics, strength and stiffness, outstanding. And because of the high filler contents, also absorbs very little humidity, is very dimensionally accurate. And then the BKV30 FN04, this is a very versatile grade, our working horse. Fulfills basically all requirements. And eventually we have to say that for this part, for this assembly, using this material, that could all be fulfilled. So this is for a Korean producer. This has reached serial production. And if you take that whole assembly that has a high degree of flame retardancy and electrical insulation, also provides the very much needed mechanical robustness against the typical vibration requirements. And it also features the high chemical resistance to lithium electrolytes. This is also something we hear from OEMs. They are sometimes concerned what happens if there's a leakage of lithium electrolyte. Also that can be done very well. So case closed, I would say, but not quite. We keep developing further our grades. So if we start with this BKV30 FN04 as the starting, it's a starting point, then we offer also different grades with different V0 ratings. Why different ratings? Because simply you don't always need maximum rating. And if you have a different rating, you can achieve better flowability, even better surface appearance. So there are different options depending on the very specific design of the parts and requirements. And I also want to show you an example from the two-wheeler world. So this is for a scooter. And in this case, we were asked again for the top FR performance, but also for very low warpage for this cell holder, cylindrical cell holder. And for good chemical resistance, again, we see this topic coming up here. And in this case, we opted for a PBT grade, PBT ASA grade, with GF12 reinforcement, excellent grade for this application. So also here we can say that on the level, battery cell holder, battery module housing, we have excellent solutions ready for the customer. Moving on, we come to the mainframe. And the mainframe is a kind of representative of EV components with metal inserts. And this is really something we see a lot. For example, the bus bar inside the battery and outside, or for such 48-volt mainframes, actuators and sensors as well. So what is the mainframe? So this is actually the connection between the battery, the DC-DC converter, and the motor. So that serves as the connection. And so here, in all these cases, we need metal overmolding. Yeah. And so what do the customer need? What does the customer need here? High and stable electrical performance, dimensional accuracy. This is an important point here, stability, hydrolysis in some cases, and typical robustness. And of course, it needs to run well on the machine. Doesn't sound like too critical, maybe at first glance. But the thing is this, PBT is often preferred for these applications due to the very stable electrical properties, the dimensional accuracy. But now is the thing, when you come to overmolding metals, then you have automatically a gap between thermal expansion of the metal insert and the plastics. And if you then apply a typical thermal shock test as shown here, then you have very likely a problem with PBT, and there's a risk of cracks. So in this case, we had to develop new material. And the aim is to have a material that has an increased ratio of strain versus expansion. Of course, we also try first in a troubleshooting attempt to improve molding parameters, to avoid flow lines, things like that. So we will simulate, we will try to optimize that. But sometimes it just is not enough, and we have to go further and have to develop according, better suited material. And I want to show you what is the outcome, and that outcome is what we call Poken XHR. This is the second generation of these HR hydrolysis resistant grades, newly introduced. Now, as the name suggests, these grades come from increasing hydrolysis resistance, high humidity, high temperature requirements. But this is only one side of the story. Equally important is that these grades have much better tensile strain. So that 20-25% more makes all the difference in these overmolding situations. They also feature increased long-term heat aging resistance. So what you see here on that chart is so the Sharpie impact over 3,000 hours, this is a long time, at 150 degrees. So as you know, Sharpie is the most sensitive material factor. So if we can keep that stable, we can keep everything stable. So and that, you see the performance, this is quite impressive. And last but certainly not least is how is it on the machine? And what you see here is the melt flow rate. When you look at XHR, it's the same. All the bars look the same. That means even if you have the material a bit longer in the machine than you actually should, it will not crack down. And the flowability is also pretty good. So it's you have stability and ability combined. So this is a very good result. Eventually, now how does it transfer to the real world situation? So we come basically from the center. The center picture is the one we start off. We take a halogenated PBT, even an HR grade, and then we realize these cracks very soon, 50 cycles. When you look at the left-hand side, now if you use the latest XHR grade without flame retardants, I have to admit, then you can pass. You can get to 300 cycles without a problem. If you go for the latest grades, which are flame retardant and XHR, you may still have cracks under a certain number of cycles, depends on the geometry, but a huge improvement. I show that also because it is still a challenging situation. The combination of flame retardancy, halogen-free flame retardancy, and improved strain is still a pretty difficult one. But we can, with the new grades, we can achieve a situation, a performance that is very promising, and along with I would say a decent tool concept, this can work very well. And it's very important for all these overmolded components, such as a mainframe. Now we move on to example number 3, a charging inlet. So charging components were, of course, one of the first components to be made of engineering plastics. They were the most accessible ones, I would say. And they're also not unimportant because every plug-in hybrid car, every all-electric car comes with some sort of charging infrastructure, with charging inlet. So let's look into this. First, in this overview, you see the different standards that we can find now around the world. GPT type 1, CCS1. I think currently we see a clear tendency to the CCS2 standard to become a global standard. It also shows you that these parts, it gives you an idea, these parts are not so small actually. A complete charging inlet can weigh 500, 600 grams or even more. Now, part requirements, mechanical robustness must be used, insertion and withdrawal many times. Electrical insulation, of course, heat aging resistance is a thing, chemical resistance. All kinds of fluids can actually, can the part be exposed to cleansing agents, even drinks, sun lotion, whatever. And I would say that translates into material requirements like this: high mechanical stiffness, strength, electrical performance, especially CTI, flame retardancy. Here it is again. We cannot bypass that. And also particularly an outdoor listing on the yellow card, F2, but mostly an F1 listing is requested. Now, is that so difficult to fulfill? Actually not. Solution is here, and I will only touch this very briefly. We have seen these grades already introduced before, halogen-free, flame retardant, PA and PBT grades, and we have plenty of them who also have the required listing, including the F1 listing. So actually not a big deal. And I also have an example here by company Jura as a combo charging inlet. You see it has all, it checks all the boxes and is approved in a serial production in Jura, Korea. So why am I showing you this if this is so, so easy to do, so piece of cake? The thing is this, now you look, the entire part currently is usually made of a flame retardant material, halogen free with a top rating. Is that necessary? Isn't there maybe a smarter solution? And how about the heat buildup during the fast charging? Because this is really an issue. Everyone wants to have their huge battery charged in a few minutes. And so we need to get the heat out of these insulating parts. So that's why we thought about a new concept for these charging inlets. And that concept includes a few key components. So first we have that front housing, the major block. Then we have the so-called mask. In the back you have a housing. Then of course there are pins. There's an actuator. That actuator actually locks the coupler during the charging. And then there's a pin holder. This part is new. And of course we have wiring. So what's special about that? The core element of this concept is the pin holder. So this pin holder, what is it doing? So currently it does not exist in the current solutions. So it keeps the pins in place. It manages, the wiring. It takes up the PCB. It is also a wire strain relief. It can even help to measure the temperature in there. And that is now the vital point here. It can support the cooling. So what if we introduce this pin holder and use thermal conductive plastics for this? And here we I'll show you a little simulation of how that looks. Here's a little movie. Yeah. Yeah, well, was supposed to a movie to play. It doesn't play. Okay, so I have to explain. So on the right-hand side, we see such a pin holder made of a standard material, P6GF30, and the left-hand side, you see that in a thermal conductive grade. Now, well, I have to explain the outcome. The outcome is that, of course, with the current loads that we have, voltage loads, we have much more time to get to the same temperature point. And in fact, these are several hours to get to that point. So this gap here is all that makes the difference. So introducing the pin holder in thermoconductive material can actually dramatically help cool down the charging inlet. This is one core of the concept, but there is another thing. That leads us to the cost point of view of this concept. If we go like before with one material, let's say, yeah, the flame retardant halogen-free material, so this is our reference point, 100%. So if we go for a high-end solution, we use even for the pin holder, thermal conductive flame retardant material. And for the other parts, we use more standard materials, but or suitable for outdoor use. We already achieve more than 10% savings. And we go further. We use for the pin holder non-flame retardant, but thermal conductive material. Now we save more than 20%, and we can go for cost optimization even more. So then we reach about 30% reduction. So this is a good example of if you use a modular concept and use the materials that are really needed for the particular part, you can save quite something. So that is a demonstration of a smart concept, right? Really squeezing out what is possible here. Now I mentioned thermoconductive materials. Quickly, the materials at a glance. We have a portfolio of materials, some shown here, complicated names. Just want to mention here, we reach about 1 point something to 2.5 watt per meter Kelvin. Sounds little. And we sometimes hear customers asking us for 10, 20 watt per meter Kelvin. The thing is, all our grades are electrically insulating. If you want both electrical insulation and thermal conduction, then there's a limit. So we cannot reach very high, but we also don't have to. We know from several applications that something like 1, 2 watt per meter Kelvin is actually enough for the application to lower temperatures by 10, 20 degrees. We can help you simulate that in the first step if you are doubtful that this is enough. But for many applications, it definitely works. And we move on to the next example, and that has to do with a high voltage connector. Again, one of the first applications that came in engineering plastics. So here the challenge was orange. We mentioned that before. Orange is needed for everything that is actually carrying voltages above 60 volts. So this is the common standards, common understanding. So it serves as a safety feature for repairmen, for firemen, for everyone who is exposed. So everyone instantly knows, okay, so this is dangerous. And it must be, of course, identifiable for many years to come. It must not turn black or brown, right? So the customer's target was a connector in the color 2003. And it might only change between 2003 and 2010 over lifetime. We need also a valid yellow card in that color. and it should not be outrageously expensive. Orange pigments are not exactly cheap. And of course, we also need some fundamental properties listed here. Sounds not too difficult if you're not too familiar with the details. And orange colors we know from the E&D industry, but not exactly with typical automotive requirements. And a little excursion into polyamide. Now, polyamide, as you can see here, 130, 140, 150 degrees, it turns brown. After 1,000 hours, you see this is quite a lot. There's a natural tendency. So we can, first of all, we can stabilize that. This is the right-hand side pictures. These are the right-hand side pictures. So this is quite something, quite stable. So this is one step we have to take. But the other step is we have to change the color too. So eventually we did two things. We stabilized the material from yellowing, and we also made the color very brilliant and very stable. So we come from this one here to a much better result here, even 140 degrees. And what you see here, what we call this 400, this is an additional stabilization for very high temperature requirements, 150 degrees. And yeah, we still are in the range of 2010 at that point. So it's a very stable situation. Now, for the other major pillar of our materials, PBT. Yeah, with PBT, this is a lot easier because PBT doesn't discolor in a similar way as PA. So PBT, yeah, you just look at the picture, everything looks the same, right? We have two different grades here. One is halogen-free, one is halogenated. It doesn't matter. Temperature, it doesn't matter. It's very stable. We don't need extra stabilization, but we still need a good color, of course. Also a color that is stable in processing, not just in aging, but also in processing. So this is done, doable, and it works very well. And a short remark about the colors that we offer in orange. There's different ones. Yeah, RAL 2003, 10, and also 11 is actually a smart solution. It is better than 2010, more brilliant, but more affordable than RAL 2003. So this is what we recommend to customers. Eventually, customers decide what colors they definitely want, but we have different options. So finalizing this part, our toolbox for orange parts, what we offer with our grades is we offer all the needed fundamental properties and the coloration and the stability. And you see the little remark here, they are covered by our yellow cards. So when customers decide to go for master batches, then this is not the case. Yeah, when you buy the material pre-colored from us, it is the case. Yeah, so this is the safe option. And I want to finish my presentation with a battery outlook. And yeah, this is really an outlook, battery housing outlook. Not yet a case study. But I also want to go into this to show you what is possible. We're already working on this. The requirements are high flying, very high mechanical requirements, side pole impact, crash, electromagnetic shielding, flame resistance. And also the package space is not big. Everything should be filled with battery cells rather than the housing, right? So replacing here aluminum die cast and steel is not an easy ride. And here I want to take the opportunity and introduce to you also our high performance composite Tepex under the Tepex brand. So that comes in composite sheets with endless fiber reinforcement. We can use glass, carbon, ceramic fibers, also hybrids. And so these materials feature very low weight at very high stiffness, strength, and energy absorption. No corrosion issues, of course, and no investment for additional tools. What does that mean? The parts can be formed actually by the injection molding tool, which is used to overmold the formed Tepex with engineering plastics. So this hybrid concept here is part of that clever concept. I'll show you an example for Porsche. These brake pedals were the first brake pedals in the world without metal. Why? Because it's led to a weight reduction of 50%, roughly. Functions could be integrated, process steps simplified. This is a hybrid of Tepex and urethane. A lot is possible with this material, and also in the battery housing, what we think of is, of course, elements that absorb crash or provide extra strength and stiffness. There's another aspect I wanted to show you, and that is a kind of inherent flame retardancy of Tepex due to this long glass fiber, endless fiber reinforcement. Unfortunately, also this movie doesn't play here. I don't know why, but it's a pity, really, because it is highly impressive when you see the Bunsen burner really hitting that sheet, and it doesn't really do harm. This is pretty impressive. So you have to just believe my words. So there's a very strong inherent flame retardancy of these grades, and combined overmolded with flame retardant polyamide, that is a very strong alliance for very demanding parts. With that little outlook, that of course is really a very challenging field, but very interesting one. I want to finish the quick ride through these project examples and outlook, and thank you for your attention.
Thank you so much, Jürgen, for that wonderful and very detailed presentation. You finally touched upon the topic that we were talking about, batteries and the innovation on the battery front. So still, if you would, I would request all our attendees, any questions that they have, they can type in the Q&A box or the chat box. We can simply take it up with Jürgen, and he'll be very happy to help you with the answers. Meanwhile, Jürgen, I would want to again touch upon, some of the critical innovations that we were talking about with respect to batteries in EVs, particularly if you can shed light what is happening in the Indian context.
You mean by new applications or in the battery segment overall?
Absolutely, yeah.
Yeah, overall. There's a couple of things happening. So the one thing I showed also is the battery on a battery module level. So this encapsulation. So this is already happening, as I showed in my example. Of course, the tendency is to make these modules as small as possible, as thin as possible, so as not to use up a lot of space, because the cell, of course, is supposed to take the space. So this is the one development we see strongly. Then the bus bar, overmolded bus bars is a major thing, because it's not easy, surprisingly difficult actually to make this work. The battery housing, as I touched, of course, we see really the requirements are something, because not just the mechanics, and it holds, the key component. Really no failure allowed. But what makes it harder is the very stringent fire resistance tests around the world. Especially, I think the Chinese standard is tough. There is also a requirement for for electromagnetic shielding. This is something, that comes easy to metal, to steel especially. So providing that property to plastic housing, definitely a challenge. So there have quite a few roadblocks ahead, but there is strong interest from OEMs to do so. And as I said, we are already in a very advanced project to do so. And I hope as of now, I can't reveal more. This is still in a developing stage, but I hope that in few years, we can really show that and showcase that kind of parts. Yeah.
Right. Jorgen, there is also the concept of battery swapping, especially if you consider two-wheelers and electric three-wheelers that we are seeing for last mile connectivity in India. So with that respect, is there also innovation happening on the front of making these battery packs lighter?
Oh yes, the battery pack for a two-wheeler or three-wheeler is a bit similar in size, also in character, to a 48-volt battery. There's some similarities, and so they naturally also come in some aluminum die-cast housing, and but they also start to come now in engineering plastics. So they will perfectly apply to the two-wheelers, three-wheelers. Making simply the swapping easier to handle, right? So for the daily job, so to speak. So this definitely would be very much hands-on and very much possible to doable to replace metal here. And so this is definitely on the list. Yeah, one of the first things to do, I would say.
And do you think battery swapping as a concept picking up going forward, or people are going to just simply rely on a fixed battery which can be fast charged?
Yeah, difficult. I think for the two-wheelers, three-wheelers, I think it appears to me more doable, simply because storing all these batteries is doesn't need a huge space, and we see that in several other places, in Taiwan, in China. So that is already happening. For the cars, there has been a concept many years back, I think 10 years ago roughly, Israeli company who ventured into this. And they did not quite work out. And I can imagine this quite difficult because the batteries are so huge, and then there is no common standard. Especially for if there's a kind of standard achieved for two or three wheelers, then I think it would be fantastic. And definitely easier to do than on the four-wheeler on the car side. Yeah, there I imagine it rather difficult. And the question is it really so necessary with charging times now down to fast charging of 20 minutes and to 80% charging, at least in the metropolitan areas. We will have to see. No definite answer yet.
So with that fast charging concept, Jorgen, are you also seeing a trend emerging towards a shift from lithium ion as the raw material? I mean, are we looking more at metal air batteries and other alternatives to lithium ion?
Well, I think for the time being, lithium ion is has extremely become the mainstream, right? So in the car industry, it's hard to spot any alternative at the moment. And the lithium, sulfur, and the solid state batteries. We were all waiting actually for the introduction. I think it was introduced the first car for the Tokyo Olympics, but I didn't see that car. So still we still need some patience to see a shift here. But I think for the time being, I don't see really an alternative to lithium ion. Yeah.
Okay. And what about creating a circular economy? I mean, I also asked this question in the last panel discussion. So your thoughts on recyclability of these batteries and using the existing materials and putting them into a circular economy?
Yeah, for us, for our materials and for the components made of our materials, it's basically possible. I think the biggest challenge is really separating parts and separating them properly by type of material. So that is probably would be the biggest challenge. But I think in terms of also value and the used materials, the biggest challenge and task is really to recycle the cells, cathodes, anodes, electrolytes. And there are now programs coming up. There are projects also by the major producers to really take the batteries back and recycle them. I honestly have no insight in this, in this technology question, as it touches the battery cell chemistry. And I'm not chemist enough to answer that question.
Sure, I understand. On that note, we have come to the end of day 3 of the AutoCAD Professional EV Forum. Thank you, Jorgen, very much for your presentation. Mr. Khare, any closing thoughts from your side, please?
Oh, yes. Before that, shall we play a last video that is yet to be streamed?
Sure.
That is from Sojefi India, Mr. Prasad Sharma.
Good morning. I am Prasad Sharma from Sojefi, India. I am happy to give my experience of working with the Lanxess India. We are one of the biggest automotive Tier 1 supplier to many OEMs in India, and we make many engine parts and solutions for engine cooling, filtration, oil filtration, and performance improvement of engines. In our journey with our OEMs, Lanxess has been a very reliable partner during the last 10 years. Of course, during the last 3 years, we have strengthened our relation with the Lanxess India in a big way. We have purchased from them mainly polyamide 6,6 and polyamide 6 resins in huge quantities in order to cater to the OEMs like Ford, Tata Motors, Mahindra, Renault Nissan, and many other customers. Working with Lanxess has been very, very fruitful association for Sojefi in India and globally. Being a global company, Sojefi values the relationship that Lanxess has had with us for many years, and we always work very closely with them during any of the development projects. Lanxess has always supported us in product development and technical inputs during the design phase, and of course for the validation of the product in order to prove the performance of the material in all stages of development. It has helped us immensely to convince and give solutions to our customers and become more cost-effective and reliable supplier to automotive OEMs in India. And we also expect further new products to be developed with Lanxess, especially in electric mobility space going forward in the next few years. And we anticipate that we will have very collaborative approach for battery cooling solutions, battery fume extraction systems, and many more products which are on the pipeline and under discussion with Lanxess. We always have collaborative approach with Lanxess because they are providing us the solutions very clearly and be our joint partner in any of the projects that we have with them. To give some examples, we are now working with them for a very good solution to change from PS66 to PS6 for a cylinder head cover application. Then we also have the products that are used in elbow and mixer ducts for the engines, and definitely we have also considered them for many filtration projects which are ongoing in India. So with this, we have strengthened our relationship with Lanxess, which is growing by the year, and we expect that we will have more and more growth in business globally and in India when we have the transition to electric mobility, because that is where the action is starting now. From my side, I want to wish them the very best in all their association with us and also at global level, and become our strategic partner for all the plastic resin and new development of the products, and collaboratively achieve the business goals and acquire new businesses in order to be a preferred supplier for all OEMs And that becomes the motive for us to work with Lanxess. And the Lanxess team has always been very cooperative, very responsive, and has given us the trust and reliability, which will be the deciding factor for us to work with them as always. And I thank them for giving me this opportunity to share my experience of working with the Lanxess team in India and globally. And I wish them the very best for all their future endeavors. And we are there to support in all these activities. Thank you very much.
Wonderful. So that clearly sums up, the Lanxess's reputation in the industry and how it has adopted a customer-centric approach. Mr. Khare, your final thoughts on this, the closing of the day 3 of the AutoCAD Professional EV Forum, especially the Innovation Day that we had ideated along with Lanxess.
Sure. First of all, thank you very much to all the AutoCAD professional team. And also, I think I'm sure that when I say AutoCAD professional team, there are many people. When you make a big success like this, an event, I think there are many people who have worked behind the camera, and I really want to appreciate their efforts as well, because without their efforts, this was not possible. So thank you very much to all the team members behind the camera in AutoCAD professional team. Also, in Lanxess team, I think there are people who have worked behind the camera. My Corpcom lady Vaishali, and our team member Sachin Zagade, who have put in enormous amount of time and efforts to ensure that this Innovation Day is a success. So I really appreciate their efforts as well. And then thank you to all the speakers. Renowned speakers, very, very knowledgeable guys, very, I would say experts in their own fields. And they have taken up their time for this event and made this event a big success. Thank you very much to them as well. And then all the attendees, I think a nice number of people who have attended this 3 days session. Thanks to them as well. And then I think this event was a fantastic platform for Lanxess team to portray, what are our capabilities and what is our expertise. And then my closing remarks that, to all the representatives of tier 1s and OEMs who are present today, that, involve us at the beginning of the development cycle. And, I assure you that Lanxess will add value, and not only add value, but we will ensure that there is a win-win. So thank you very much to all, and back to you, Sumanta.
Wonderful. With that optimistic note from Mr. Khare, I would like to thank the entire Lanxess team, Dr. Tuklingsi, Jorgen, and Mr. Khare. Sumanta, over to you now for the closing remarks for the EV Forum.
Thank you very much, Mayank. Very well conducted throughout the day, and congratulations to the Lanxess Indian and global team. Today's Innovation Day really added a different dimension to the entire EV Forum, the biggest and the best of the EV Forum editions so far. So thanks for your participation. We really appreciate it. And also the panel discussions, which really brought in a lot of different perspectives, including from Mr. Sanjay Kapoor, who represented the Indian Automotive Component Manufacturers Association. So indeed, all in all, a very fruitful day, very informative day with a lot of insight. And as I said, this Innovation Day by Lanxess brought in a different dimension to the whole EV Forum. So what better way than, with such a nice presentation and discussions to end this event with a lot of food for thought over the entire day and the previous 2 days, and a lot of interesting insights, perspectives from a host of different stakeholders. Couldn't have been a broader spectrum in these. Don't you agree, Mayank?
Absolutely, Sumantra. I completely agree. I mean,
Just to add one more, Mayank. In addition to Axel, who had joined us at 6:30 a.m. today from Germany,
Right.
and also Jorgen Zelig. I think one more name I must take is Mr. Thomas Babel, who is the head of our technical marketing and who has also really contributed a lot to this event today. He is not here. He is not on in front of the camera, but I think he has also contributed a lot. So thanks to Thomas Babel as well, and to you all, Mayank, Sumantra. Nice, really a pleasure being with you here today.
It's our pleasure, and thank you for your participation and your colleagues' participation from Europe. In fact, we had a few more participation from participants from Europe in the previous days also. This also shows the overall importance and the focus on the area of electric mobility. So, and that also reflects the kind of prospects that the industry sees in the global electrification megatrend. So on that note, with best wishes to all at Lanxess and to all attendees in this forum today. It was indeed a great pleasure and honor to host this EV forum. And on behalf of Team Autocar Professional, wishing you all the very best, and equally importantly, if not more, wishing you best of health and happiness. Best wishes to all. Please take care, and till we meet again, goodbye.
Bye-bye. Thank you.
Thank you. Thank you very much.